topic, to be honest, because this argument is one of those arguments that, trust me, Globers, they're so afraid of it. So afraid of it. They don't have any answer for this GP thing, this helicopter or high altitude balloons. They don't have it. They don't have anything for it. The only thing that they can say is that the inertia, the initial velocity of the airplane would have been remain, or the helicopter would have remained its initial inertia once it's liftoff. But they don't understand physics because you're dealing with a lot of unconservative forces up there. You got a lot of drag, you got disturbances, and all those factors would have diminished your inertia, your initial inertia. So after a couple of hours, there should be a small, not a small, even like a significant difference between your initial velocity and Earth initial velocity, Earth spin. And that should have caused to land somewhere else. And this is like so crystal clear that they cannot answer these simple questions. I
You
know,
know that
I've been,
hot air balloons don't land where they took off from, right? Because they
they,
don't
they
have
do,
any kind of
they do.
they don't have any propulsion on them. So they don't take off where they landed. They're subject to the
Why
forces
not?
once
If
they
if
take
you would
off.
have, okay, let me just say, if you would have do this in a very sunny, in a summer sunny day, a clear sky, without winds, without disturbances, you're gonna almost come to the same point. Can you understand this simple fact?
Sure, but it's not going to be exactly the same point because there's always uh, slight differences in the wind, right?
No, we're just mixing a lot of things here. We're not okay.
There's always going to
Okay,
be.
I understand your point. I understand you're talking about other factors, but we're trying to only talk about one factor, and that is the spin of the Earth. That should have caused a lot of differences. That is the thing. We're not dealing. Okay, we do understand there's some winds. There would be some days that we would have typhoons, and yeah, they would have changed the position of the balloon, but you're not understanding the argument like the other globers. We're saying that if the main factor is the spin of the Earth, that should be accounted. And let me just give you the bottom line, my friend. Did you know that? Did you know that if Earth was spinning and we wouldn't need to invent airplanes? Did you know that we didn't need to even look? You could have a free ride anywhere on Earth. And this is so simple. You can go up there and
Ignores
wait for
Newton's third
24
law of
hours.
motion. It's just not accurate.
What are you talking about? Like, as I told you, when you go up there with your high altitude balloon, and when you stay for a couple of hours, let's say for 18 hours, 24 hours, like just one day, stay there for one day in those like in 60,000 feet above the ground. Once you come back down, if the Earth was spinning, you should have
But
be so complete.
the air mass is moving with the surface of the Earth.
Okay, cool.
It's
Now
viscously
you're just,
coupled. The
yeah.
air mass is
Yeah,
viscously coupled to the
yeah.
Earth. It's easy to demonstrate. If you take a
Heard
bucket,
that.
if you
Heard that
take a
many
bucket
million
full of
times.
water and you spin the
Yeah,
water
yeah.
if you take a bucket full of water and you spin the
The
bucket,
air is causing a lockstep.
the water will start
Let me just
spinning as
let me just let me
well
just let, let me
because
just
there's
let me just
You're
clarify.
saying that the atmosphere is making the helicopter stay in lockstep, then, not gravity.
it's not in lockstep because there's perturbations in the atmosphere, right? So
My
unless that
brother.
Yeah,
helicopter, the same
the
thing with the hot
atmosphere
air
has
balloon,
drag,
right?
correct? But you're saying that the force that's maintaining the helicopter over its GP, you're calling it air. You're saying that the air is doing that now.
Well, no, the helicopter has the inertia from where it took off from, and that inertia is not going to go away unless some other force
It's
acts
gonna
upon
go
it to
away.
slow it down.
That is the
So
problem. That is the problem. It's gonna go away. It's gonna go away. And this is a
why is it
problem that
going
you
to
don't
go
understand.
away? Why would it
Because
go?
we
Why
do
would that?
have drag and disturb, bro. There's some,
What's
you
the
know. Okay,
if the atmosphere is
I'll tell you,
moving
bro,
with
bro,
the
bro. I'll
surface
tell
of
them.
the
Let me
Earth?
just teach you. Do you know what is the second law of thermodynamics?
Baseless
The
assertion.
second law of thermodynamics will tell you that within the energy and work, there's always a little bit lost. The only force in this nature that doesn't cause any losses is gravity. So when you're going up there with your balloon, you cannot claim the initial inertia would have remained always. This is something so stupid.
Thermodynamics would only be violated if you're extracting energy from the system.
Yes, of course. There's a
If
lot of
there is
things. I'm
no
telling
force that's
you.
taking
I'll
the
tell you
inertia
what.
away from the helicopter, If there's no force
I tell you
creating drag,
I
the
tell you
helicopter
what you
isn't
need to
going to
do.
be slowing down from its initial from it's because the air mass is moving with the surface of the Earth. There is
Yeah,
no
okay, cool.
factor.
Okay, cool, cool, cool. Do you know what is a snow slip condition? Have you ever heard about? I want you to open this up. I want you to just Google and go in fluid mechanics. This is the most important principle in fluid mechanics. It's called no slip condition. It means that if you would have a flat plane or any surface, if you blow a wind over it, and if you look at the velocity of the air or of the air streams, you're gonna notice that exactly on the surface of the plane, the velocity is zero. And as you move up, the velocity of the air would have be exactly equal to the upstream. So this is called the drag, and it calls a boundary layer, and it really it exists in our reality. So back to the Earth. If Earth is moving with that speed, you need to understand that not all the layers of the atmosphere would have moved with the same velocity with the Earth. Those
They
layers
they
which are close to the ground, hold on, because of the no slip condition, because of the drag, because of the friction, only the lower layers of the atmosphere would have tend to move with the earth if earth is moving. And as you move upward, as you elevate, you're going to start, and this is based on science, and I can give you the function of how the velocity starts to losing its value as you move up. So it doesn't matter if you move a plane inside a flow, or if you blow a flow over a stationary plane. These are the same things, right? Over the surface, you're going to have a no slip condition. It means that if Earth is spinning exactly over the Earth, this because of the no slip condition, the atmosphere would have, since it doesn't slip, it would have moved exactly with the same speed of the Earth. And you're right about here. But this is the part that you guys are failing to understand. It is because you guys haven't passed fluid mechanics, or you guys not listening to us. When the atmosphere starts moving with the earth in the lower layers, if you start going up, you have to have a diminish of this velocity. Why? Because the conservative forces that is in nature, because it's not some because we have losses. So when you're claiming that my airplane is going up and it retains all of its inertial velocity, bro, we were talking about science fiction. Nothing can remain or holds its energy. Where nothing, no car, no machines, even a human body. We're gonna lose energy as we work. So, and I do understand that why Globers are keep saying that it will retain its energy, its inertia velocity as it goes up, because this is the only explanation that you guys can come up with to explain that stupid model. But it is exactly opposite what what's being taught in school. And I told you, no slip condition. Go study about this condition, and then you're gonna learn that why the whole atmosphere cannot rigidly move with the Earth. Period.
is there always winds aloft? Yes or no?
It doesn't matter. You're not considering
Why
any
are you
win.
scared to
Just
answer that question? You just monologued for
it,
5 minutes. Why are you scared to answer a simple question? Is there always winds aloft? Yes or no?
no.
No?
So what? No.
Go ahead and find me any high altitude chart that shows zero winds aloft.
So what's your point? What are you trying to prove here?
You created a
Trying to prove
straw
that
man, right? You said that the no slip condition exists from the ground all the way up high into the sky, right? That's what you said the Goldberg claim is,
No,
right?
he didn't
That
say
would
that. He
mean
said it's
that
happening near the
Okay.
surface. I heard him. That's not what he said.
no, he said that the Globers claim that there's a no slip condition from the surface of the earth all the way as far as you go, right? But we're not contending that, right? There's other factors in play, and there is always winds aloft. You're not going to find any high altitude wind map that shows zero velocity over any area
What
over the
keeps the
earth.
helicopter in lockstep? What is keeping the helicopter in lockstep when
The
it's
helicopter
above the
isn't
earth?
in lockstep.
Okay, so why does it remain above its geographical position?
It would only remain above its geographical position if the pilot is actively maintaining over that position, right? Because the helicopter is powered. Now, if you take a hot air balloon, if you stay near the surface where there is a quote unquote no slip condition on an early morning before there's any wind on the surface, then it will stay more or less over its takeoff point. But as soon as that
it's very easy for a helicopter to
soon as that
maintain its
balloon
GP.
starts going higher up and it gets into the winds aloft, it is not going to come down to where it started from. So this
Can you
whole
please answer my question? What is keeping the helicopter above its GP when it's just hovering there?
first of all, if it's not flying up, if there's no wind, the inertia of the helicopter will keep it over its position. If there is wind, then the
The
For
helicopter,
how
inertia of the
long?
helicopter? What are you talking about?
because it's an actively powered vehicle, will make whatever navigational changes it needs to stay over whatever position it wants to hover over.
You forgot that
But
the
from
Earth is
your point of
rotating
view,
in your
there's
model. So
always
what
a
is maintaining
rotating
it over
wind
its
mass
GP?
or atmosphere mass. My bad.
What'd you say?
No, from the globe spinning globe position, there's always a rotating mass of atmosphere, so it should always be carried. And then if it's always carried and always lockstep, if you turn around and go the other way, you'd have to go through all that, go against all
Because
that. And
You said it's
pilots
always
don't account for
carried.
that.
So the air is what's keeping the helicopter in lockstep, according to you.
yes, because of Newton's third law, an object in
Not
motion stays in
gravity.
motion
Okay, so now it's
until
no longer gravity keeping you on your GP. You have a new globe model.
no, no Glober said it was
And
gravity
Jake,
that was doing that.
has there ever been any demonstration in the lab of a rotating ball, rotating a massive atmosphere and something, staying in place like that?
No,
Yes,
you've
you can
never
simulate
demonstrated
that.
your globe in a
I
lab.
did a simulation
Absolutely
based
not.
on that. Yeah, that you can do it. It's pretty easy. You have to go to some of these package up engineering softwares like Gambit and Fluent is very good. You can use also
Talking about fucking
SolidWorks.
software? What?
Use SolidWorks. So it's pretty easy. All you have to model a sphere and
We're not
define
talking
it
about models, bro. We're talking about a lab. What?
These guys are saying that the
No,
air is pushing them. They say that the
no, I'm
atmosphere
trying
is
to help
keeping
the
them in
Globers here.
lockstep.
I'm trying to help the Globers. So now here's the problem that these people have. He would have still think that the inertia would have kept the airplane up there. He would have think that initial inertia would have always be with the airplane or the aircraft. This is not the fucking case. I told you, this is not how your reality works. Let me give you a very small example. If you stay in a car, if the doors will be open, windows will be open, and if the car goes with 100 kilometers per hour, if you throw a ball, the ball's gonna come back to your hand. And this is the stupid analogy that you Globers are always making up. But once you open the fucking window, or if you stay on the rooftop car, and if you just drop the ball up, it's not gonna come back down. Because the car is going with a different velocity in the atmosphere above it. Only the atmosphere close to the car might gonna move with the car, but above the atmosphere, above like 2 meters above the car, wouldn't move with the car. So if you just drop the ball so much high, it would not come to your fucking hand. Because you know why? Because it would have lose. Now this is the point. Listen,
Correct.
it would have loses its inertia in the first place because it's going to a different layer of atmosphere with a different velocity. So when the helicopters goes up there, you need to understand those layers have a different velocity. Some of them are moving with the ground. Some of them start moving slower. So when that helicopter goes up, it will deal with a lot of these different differences, and that would have decreased its inertia. So don't bring up the third law of Newton every time, and don't think that by using these terminologies, you guys can make everything correct. The third law of Newton has nothing to do with here. It has to do with here, but you need to make it more completed. You need to add the loss of energy. You need to add the second law of thermodynamics that it would have lose its energy. You
Well,
cannot
you
keep
heard what
saying
he
that it
said.
would
He
have.
said that helicopters actually don't stay above their GP. Like when a helicopter takes off and it's just sitting there hovering, that the Earth is actually moving underneath it. But we could actually see helicopters remain above their GP and they're not accelerating forward or backward
No,
to
I don't
maintain that
understand why
position.
this is so confusing for you guys. The
It's not.
helicopter
It's
will
very
retain
simple.
no, the helicopter will retain its inertia unless it's acted on by another force.
So
That other
Jake,
force
Jake.
is going to be the whatever winds are aloft, right? And
Okay, Jake.
sure,
Let me get
sometimes
in real quick.
you'll get the zero slip condition near the surface of the Earth, but whenever you go up higher up, there's always going to be winds aloft. That helicopter is going to have to actively propel itself against the wind in order to stay over its takeoff position. Otherwise, it's going to drift with the wind, the same way a hot air balloon will.
All right, so let me get in real quick. I know everyone can hear me. Don't start talking now. It's too late. I'm already in. So Jake, if we took a sealed room, completely sealed room, no air can get in, no air can get out, and we just put a helium balloon in it, a helium balloon so that its density had it sitting in the middle of the room. You know what I'm saying? It wasn't going to the ceiling. It wasn't falling on the floor. We had it just right. We put it in the dead center of the room. You're telling me because we're on a globe that balloon's going to end up towards the eastward wall or westward
That's a
wall,
good.
whatever one it is?
No, it would because there's no forces acting upon it because the air is still in that room. Then it will just stay in the center of that room. And if you repeated that with a semi truck, if you took a semi truck and you hover this equal density balloon where it will just hover in the center of the semi truck, as long as the semi truck is not accelerating or decelerating, if it's at a steady speed, that balloon will stay in there. And you could put it onto the floor and then lightly raise it up. And because
Yeah,
of
but
Newton's laws of motion, an object in motion will stay in motion unless acted on by another force. There's nothing that's going to make that balloon suddenly lose its quote unquote inertia because as long
yeah,
as
but
the air mass in there is steady, there's no force slowing that balloon down.
all right, but does this no slip condition not apply to inside the room that we sealed off with the balloon? Please don't change the scenario. Can we just stay on
The,
the
the no
scenario for
slip
2 minutes
condition.
without jumping from scenario to scenario to scenario, never coming to the
Well,
conclusion of any scenario?
there's two things to consider with that no slip condition. Also, is that the air at the top of
Oh, you cut out, Jake.
my daughter driving me nuts. Where was I going with this?
Somebody told him he was about to debunk Cavendish, and they shut him down.
The no slip condition wouldn't apply to the surface of the Earth because the top of the atmospheric layer is not being slowed down. There's no force acting upon it to slow it down because it's in the vacuum of space. There's no friction being created at that location.
So you're saying that no slip condition is not valid for Earth? So so let me just so you're saying that as a grown person, you're saying that the no slip condition principle in fluid mechanics is not applicable on Earth. Is that right? Is that what I heard?
No. The mechanics are still the same, but the difference is when we're talking about the no slip condition of a boundary layer over the surface of something that's traveling through, let's say traveling through an air mass. You've got you've got the air mass that will you've got the air mass that's being accelerated near that no slip condition on the surface, but then at the same time, as you go further and further away, the velocity drops off that you see in those diagrams with the no slip condition. But
Excellent.
that's because
Excellent.
but that's because but that's because you have an object that's moving through an air mass, and the rest of the air mass is not moving, right? Relative to the object that we're looking at. But in the case of the Earth's atmosphere, you've got the surface of the Earth that's imparting that's dragging that mass along. But which is a little silly to say that because that air mass formed over the eons, right? It's not like that. It's not like suddenly the Earth was spinning and then a giant came in and filled the Earth up with an atmosphere. That's not what happened, right? All of this formed together. So all that inertia was happened during the formation of the solar system. But
So
regardless,
what?
you don't have some kind of friction that's exerting you don't have something that's exerting some kind of a friction on the surface of the atmosphere, in space, where you would have this weird thing where you have the atmosphere dragging against something stationary in space, and then you have the Earth spinning underneath it, right? That's not what's happening.
So you're saying that basically just because we have vacuum out there, the no slip condition is not going to work, and we're going to have a no slip condition everywhere. So you're saying that. So this is the thing. Let me just break it down. That how much what you said is stupid. You're saying that just because we have a very special case, just leave all the fluid mechanics, everything that you learn is just throw it away. On the Earth case, we have a very very special scenario. We have a vacuum around it, and this vacuum around the Earth would have caused that no we shouldn't it will cause that we shouldn't have any no slip condition at all, not from the
It's an
ground all the way to the
you gotta grant them anti-gravity vacuum too. Anti-gravity.
no. Look, listen what he said. He's saying that we don't have a no slip condition from the ground all the way to the
Yeah,
up.
because the
He's saying that
typical diagram, like you've seen the no slip condition diagram, right? Where you have a stationary plate and a moving plate, and then you have a fluid between the two, right? But that's not the condition of the Earth, because what we have essentially is what it would be more akin like is if imagine that you had like a conveyor belt, right? Imagine you had a conveyor belt that had like a little dams on the side that could hold water, right? If you fill that thing with water, if you fill that conveyor belt with water, imagine it's a conveyor belt that goes for miles and miles, right? You fill that conveyor belt with water, eventually that water is going to get up to the speed of the conveyor belt, and there's going to be a no slip
because it's
condition from
constrained
the
because
there's going to
it's
be a no
for the
slip condition from the bottom of the water touching the
now this
belt
is a
to
different
the top of
analogy.
the water, because there's no there because other than the tiny amount of air friction there's which is very low compared to the mass of the water, there's going to be the water is going to be moving lockstep with the belt. Do you not agree?
Yes, of course, because you're pouring the water inside a container. What are you talking about? You're just
It's a
making a very analogy.
we're talking about a fluid that we started off as stationary that we accelerated with this conveyor belt, right?
So,
The
okay, okay,
same
just
the
pour
same
the water,
the same
pour the water. Okay, I got your
I mean,
point.
I don't
No,
know why
okay,
you have to
pour the
spiral
water
here because it destroys your point, but
instead of
there's no need
pouring
to
the water.
spiral.
Bro, instead of pouring the water inside a container and put it in the belt in the conveyor belt, why don't you just pour the fucking water over the conveyor belt and see what happens? And if you do that, you will see the no slip condition. You're gonna see
Okay, so the
exactly
water
those tiny
droplet,
layers.
the
Yes,
water that doesn't run
if
off
you
the
pour,
belt,
if
the
you
water that
pour,
doesn't run off the belt, the water droplets are going to be in a no slip condition all the way from top to bottom, are they not?
yes, it depends on if it would be a solely only water, yes. But if you put the water inside a container, like a dish or something, and if you put the dish on the conveyor belt, yes, of course, it would have moved always with the water. But if you without any dish, without any container, if you just only pour the water on a conveyor belt, and if the conveyor starts to moving, you're gonna see that no slip condition or that function that I'm talking about, which tells you that only the very, very tiny layer which is connected to the object would have moved with the same velocity. And as you move up exponentially, you're going to see a diminish. So even if you want to know that but based on what function this slip no condition or this velocity will decreases, it's exponentially. You can just look at it right now on the net, just type no slip condition, and you can see this exponential function I'm talking about. It's y versus v, or it's velocity versus height. So if you look at the figure velocity versus height, you're going to see it's an exponential function. It tells you that the more you go up, you're going to see more drop of the velocity. My brother, this is a principle in science. And it's so, and let me just clear this out and then I'm going to mute on. Look, I don't know why when we talk with Globers, you guys are so selective. Whenever you guys want, you're going to bring up gravity, you're going to bring up some scientific terminology to explain some of the things. But when we use the same principles in science to debunk the globe model, you guys come up with very strange scenarios. For example, right now we say that because Earth, there's a vacuum around the Earth, everywhere would be a no slip condition. Because this is what you're saying. When you're saying that the whole atmosphere is rigidly moving with the Earth, you're talking about that all the molecules are going into a no slip condition. Bro, this is unbelievable. This is exhausting. Like really we're
You're,
frustrated from you, Globe.
because you're not using the no slip condition in the correct context. The no slip condition is always about some surface that's moving through a stationary air mass, or a moving plate sliding against a non-moving plate with a fluid in between it, right? There's where you're going to have this where then you're going to have this gradient of speeds where you go from the no slip condition on the surface of the moving plate that's interacting directly with the fluid to to the rest of the fluid that's interacting with the rest of the stationary fluid,
Upstream, yeah,
that right.
exactly.
And so this is where you're not using it correctly when it comes to the Earth. The way that the Earth encloses the atmosphere within it like a container because of gravity is in the same way that the dams on the side of the conveyor belt will hold that
Oh
water and
yeah.
move along with the conveyor belt.
Oh my
And if you can't understand
god.
that analogy, I'm sorry. It's just maybe you don't have
Bro,
a good
no slip
understanding of
condition.
fluid
Bro,
dynamics. It sounds like
look,
you have a
bro.
very
In no
remedial
slip condition, you don't have
fluid
any
dynamics.
gravity. We don't have any look, bro, I studied this shit in school. We don't
Okay.
have any GP.
Okay, let's see if that's true. Because flat
We
earthers
don't have
always
gravity.
lie. Flat earthers always lie. So let's test some of your fluid dynamics knowledge because flat earthers always lie. Okay. So let's
Oh
talk
my God.
about supersonic flow versus subsonic flow and a choke point in Bernoulli's law and how that changes and why. Can we talk about
Yeah.
that?
So you want to talk about this is so fucking simple. Subsonic is under Mach 0.3, and supersonic is usually above Mach 1. And above Mach 2 and 3, it will be hypersonic. Well, I don't know why you're trying to change the subject, but here's the thing I'm telling you. When you look,
How does sonic flow? How does supersonic flow? This is like remedial fluid mechanics. Okay.
Dude, why are you changing
How
the
does
subject?
I want to know if this
Ask
guy
him a
actually knows what he's
complex
talking about.
question. Why are we doing remedial stuff?
How does supersonic flow through a choke point change compared to
It's irrelevant.
so
subsonic
when you're
flow
going to
Forgot there was a topic, dude.
and Bernoulli's principle?
Yeah, the Bernoulli principle tells you that the total pressure is a combination of a dynamic pressure plus static pressure. And the choke thing that you asked from me is that yes, when a flow hits the Mach 1, it will create a sort of a barrier inside the nozzle or inside the wind tunnel, depends on where you at. Or if you're in the outward air, like the airplane that is moving in the atmosphere, once the airplane reaches Mach 1, you will create a sonic barrier in front of the airplane. And that will always be with the airplane. And the more airplane goes faster, the barrier starts attaching to the body. And if you go very fast, it will cause a failure. But I don't know why we're going here. We were talking about the no slip condition that you globals are saying that the whole atmosphere doesn't it slips. Sorry, it doesn't slip. So you're saying that the atmosphere doesn't slip as the Earth is moving. This is crazy. This is not based on science. We know that the fluids will slip when there is a moving object, or if they go on a moving object, or if a moving object goes through it, there would be a no slip condition. And I told you, I gave you the function. And I'm telling you, you globers are that this is the crazy part of you globers. You guys are saying that you guys are against science. You are literally guys are against science because you're saying that the whole atmosphere is not slipping. Can you understand this simple thing? It doesn't make sense. Hello? I don't. Can you guys hear me? Okay.
Yeah, you wrecked them, bro. That boy doesn't have an answer. Jake the plane.
I told you I love this argument. I'm really sometimes serious about it.
You just don't know how to apply the non-slip condition. You didn't answer my question, by the way.
He's reading Chat GPT.
No, I'm not. I'm arguing with my daughter here over who's going to take her to her class. It sounds to me like you're just misinterpreting the no slip condition.
Oh, you're misinterpreting
my
why a helicopter can remain above its geographical position. You're saying
It
the Earth
doesn't.
is moving
It
and you
won't.
don't detect it, and the atmosphere is pushing the plane. All kinds of dumb shit.
I mean, it just comes down to Newton's laws of motion, and unless there's some force that acts on that helicopter, it's going to
The third
continue to
law
move.
is that there should be an equal opposite reaction. What does that have to do with the helicopter?
First law. We're talking about the first law. An object
You
in
mentioned
motion.
third law. All right, so you're talking about.
I'm sorry, I might have misspoken then. But either way, if we look at it, there's always winds aloft. So the upper atmosphere is never in lockstep with the surface of the Earth, right? And more importantly, here's the better question. Why are the jet streams around the world predominantly west to east? Why? Why is that? Why on the flat Earth is the jet stream predominantly west to east?
You know what? One of the reasons that I turned into a flat Earth was it was people like you. To be
Kasra,
honest,
can
when
you
I
answer the
saw
question? Kasra, can you answer the question?
literally like no,
Yeah,
in
it's just a
every
Can you answer
dishonest
the
globe
question,
batting
please,
technique.
Kasra?
Well, on a flat Earth,
Because
there's
I can.
still
You want to change
sidereal
the topic?
rotation.
Yeah.
There's
He
measurable
thinks something
No,
else
this
sidereal
is
is
directly
rotation.
related to his
because he
conversation
knows that the
about.
helicopter completely conflicts the globe. So now he has
No,
to
no,
talk
this
about
is
something
directly
else.
related to the conversation because we have a good explanation, and it does relate to his no slip condition situation, which talks about a fluid interacting with a surface. that explains why the jet streams on the surface of the Earth are predominantly west to east. Now, Kasra, do you have an explanation on the flat Earth why the jet streams are predominantly west to east on the
On a
flat Earth?
flat Earth or a stationary globe, there's still sidereal rotation. So I mean, it's not really.
Yeah, but how is that? How is that?
Gotcha.
Hold on, we're talking physics here. How is the
Okay,
sidereal rotation
that's a
applying a
long
force to the
story.
air
That would
mass?
be a long story.
How is this?
That would be a
How
long.
is
I'll
Kasra?
tell
Can you
you. I'll
please
tell you.
answer the question?
I'll tell you. The reason that we have jet streams, the reason that we have hurricanes clockwise, counterclockwise, the reason that the focal pendulum moves clockwise, counterclockwise, above and below the equator is all because of a one reason, my brother, one reason. And that is called the inertial sphere upon us. We flat earthers believe that yeah. So if you think that, so either you think that the earth is moving or you have to think that the sky is moving. You guys believe that the earth is moving. We believe that the sky is moving. And you need to understand in physics, both works. Okay. So this question is
How is
not
the
a very,
sky? How is the sky imparting a force on the pendulum? How is it imparting a force on the air masses?
Newton's buck.
Newton's law. So here's the thing.
Because
If you look at the
here's
stars,
my question. Here's my question. Over the equator, if we look at the celestial, if we look at the stars, they're traveling directly, east to west over the equator,
exactly.
right? The
Great,
stars are
great. That's a
traveling
focal
east to
pendulum.
west. The stars are traveling directly east to west over the equator when they're over your when you look over your head on the equator, all the stars are traveling east to west. So we should have
Good
the
for you.
strongest inertial sky bullshit that you came up with. But we don't have the
No,
jet
no, no.
streams over. But we don't have the jet
I'll tell
streams
you
over the
exactly.
equator, right?
No, no.
The jet. We don't
Okay.
have any jet.
Bro,
But we
bro,
don't have
bro.
any jet streams over the equator. Why are there no jet streams over the equator?
Okay, calm down, calm down. You ask your question, I understand. But you're saying that okay, on the equator we should have a much more stronger bias, but on the contrary, on the equator you have no bias. That's why the star trails don't go, and that's why the star trails look straight. That's why the fucking focal pendulum goes
But you told
straight.
me that
Listen,
motion of the
listen,
sky.
listen,
You told me that the motion of the
listen.
sky is what's imparting the
The
force
motion of the
to the
sky.
air
Okay,
mass.
so the bro, hold on. Let me just explain it to you. Now, this is
And
based on the
by the
triple
way,
flare.
we're gonna bring in quantum erasers experiment. What experiment have you conducted that's demonstrated this inertial sky force? What experiment have you conducted using
You're
quantum
asking a
eraser
lot of
steps?
questions. Bro, calm down. You're just asking a lot of
Well, you
questions
made
one by
this
one.
claim. You made
So,
this ridiculous claim that
so
you're not going to be
yeah.
able to substantiate, and we're all going to laugh at you.
You're observing an effect, okay? You claim that you've observed the cause of your effect, and you have not. You just haven't.
You know what I'm asking?
We
This is
we
normal
can
for globers.
demonstrate all the
These are
physics
regular.
of the jet streams on the globe Earth. You cannot
No, you
demonstrate
have a
physics
model. You
of the
propose the
inertial
reason for the
sky.
jet streams is due to Earth rotation, but you did not observe the direct cause of your effect. Admittedly, in your
Well,
model, you cannot
all
observe the
scientific
cause of
tests
your
using
effect
known physics, all known tests
because you're
using known
within the
physics
reference frame.
demonstrate the rotation of the Earth. There are zero tests. Am I right or am I wrong that there are no scientific experiments that demonstrate on the flat Earth the inertial sky
You're wrong.
You have an
We have
Kasra made
you have
up?
we
an
have experiments.
unfalsifiable claim because you're in the reference frame of the motion. You can't detect what's causing the force.
What do you mean we're in the reference frame? All
Yeah,
reference
you say
frames are
that you're
happening
on
at
a
all
move. You say
times.
that
What are you
you're on a
talking about?
moving Earth. You say that you're on a moving Earth, and therefore you can't measure the force because you're in the reference frame.
This is ridiculous. Pastor, do you have any evidence? Can you show me a scientific paper about the inertial, or I'll accept any paper from anybody, even
Bro,
Well,
people
we are
that are
flat
rejected
earthers.
by,
We
even people,
we don't have a
even people
platform.
rejected by the
brother.
scientific community. Anyone that's done any experimentation to show the inertial sky force.
Yeah, if you look
Yeah,
at
you're changing the topic a lot,
interferometry,
dude.
brother, if you look at interferometry, it shows, look, we can't detect an orbital motion, but we can detect a sidereal rotation, right? So just that alone, that shows you we're not moving. The same technology can measure the movement of the stars in the sky, but it can't detect our orbital motion, right?
There's a good
Follow me?
explanation for that,
Okay. All right. We
but I'm
haven't
not going
heard one yet, but
Yeah, you have an ad hoc explanation. You did not confirm that the cause is a spinning globe.
I still want to know about this inertial. I want to know about this inertial sky and how
Okay,
how it's
let me just
imparting.
go for 1 minute.
Can you explain to
You're
Let me
me,
go
literally
for 1 minute.
Kasra?
describing it
How do
right
I
now.
measure?
You
How do
said,
I
I want to
measure
know
the?
how you have an inertial
How do
sky.
I
That's
measure?
exactly what's happening. Good job. You
How
explained
do I
it.
measure? How do I measure the inertial sky and how it's interacting with the
Okay,
stuff on the surface of the Earth?
Use a
Kasra, what experiment
gyroscope.
can I do? What
Use a
experiment can I
yeah,
do,
yeah.
gyroscope.
Kasra?
You could I got an experiment. It's called Newton's bucket, right? You take a bucket, you fill it with water, and then you spin the bucket. The rotational system of the bucket transfers, centripetal and centrifugal forces inward and outward, so the water comes up the sides of the bucket, and creates like a tornado effect.
This is
That's
related
the
to
same with any
Kasra's zero slip
rotational system.
condition
It
because
transfers
you have
it
you have you
transfers
have
the motion.
you have the surface of the molecules of the surface of a solid interacting with the molecules of a fluid, and that's perfectly understandable why that would happen. But the
Okay, so
inertial
a
sky,
rotating sky,
the
a
inertial
rotating
sky.
universe, for matter of fact, a rotating universe, the whole entirety of the universe that you see is rotating around you. You don't think that transfers any motion?
The inertial sky, the inertial sky. I mean, are you guys going to say? Are you guys saying that the dome is now a rotating dome?
Can
Is the
you
dome
gather your thoughts
rotating?
before you start
I
blurting
mean,
out
there's a
stuff that doesn't
measurable
make sense?
sidereal rotation. We can measure it for a fact.
But
So
what's
yeah,
imparting
it's
the
rotating
force?
around us.
What casserole? What physical effect is it? Because you sound like a science guy, right? You like physics. So tell me what. How does how does that interaction impart a force on the fluid, the inertial sky? How does it impart a force on it?
That's a very good question. I really like your question. I call it the fabric of space-time in my uh, cosmology. It's I believe that these two polar vertexes, one on north, one on south, they're causing these biases. And here's a proof for it. Here's a good proof for it. Listen to me very carefully. If you look at the star trails, the rotation on the North Pole, you're going to see that they're going to counterclockwise rotation. Check this out. So the stars on the north they go counterclockwise. But if you look at the hurricanes, they go clockwise. What does it remind you? Third law of Newton, right? When something goes when you exert a force on something, that thing will exert the same amount of force in the opposite direction. So if the sky on north is going counterclockwise, things on the ground have to go clockwise. That's why the focal pendulum goes clockwise and the rest of the things. This is the best way that I can help you right now. But if you want like a lot of scientific equations, like how this
No,
inertial
no scientific
sphere is
equation. I just want to know the mechanism because
no,
you just made this claim,
I just
but
gave
you
you
haven't
another.
described the mechanism. How is that? How is that force of the sky of the star trails? How does that translate into an actual force that's moving an air mass? Right? Because we're talking about something is actually moving that air mass. And where do we go from star trails moving overhead to moving an air mass?
Newton's
Where
bucket experiment.
how is that force being translated? What is the interaction?
Newton's bucket experiment.
Because on the globe Earth, it's because the surface of the Earth, which is made of matter, it's made of a solid, molecules, is interacting with the molecules of the fluid, right?
Yeah, 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 yeah.
And there's an
I'm afraid. I'm afraid.
there's an
No, yeah, it is. It is.
there's an
It is. It
electromagnetic
is. It
interaction there.
exactly. It is. It is something that. But I'm afraid. I'm afraid that I cannot open that right now for you, my brother. I don't want
Okay,
like
so
this
it's
is not
just
because I'm.
bullshit. It's just bullshit that you made
No,
up.
no, no.
Thank you.
It's early it's early for you. Okay, I don't want to mess up with your mind right now. And I know you're because when you
Okay.
ask these questions about well, you're new to this, and I don't want to do it right now because if I tell it to you, you're gonna start laughing and saying something like that. I don't want to do it right now.
Well,
Give me time, bro.
you're not gonna have a scientific experiment for it, right?
How do
I
you do a
just
We can
told you.
create
scientific
a
Newton's bucket
experiment
scientific
on
is
space
Newton's
experiment
time?
to
How
bucket.
do you
show
prove
we can
space
create
time?
scientific experiments to show the zero slip condition between a fluid and a solid, right? We can create that experiment. You have the experiment to show the star trails
I'm glad. I'm glad that you thought
interacting with the
about it.
massive fluid.
I'm glad that you educate yourself about the no slip condition because a lot of Globers don't know about those no slip conditions. Otherwise, they won't be a Glober. Anyway, but yeah, that would be some. That, as I said, that is a good question, and that why and how this thing is working up there. That's a $1 million question. I'm sorry, like that's the whole thing. That's what you're asking here is about the whole principle of physics, like the general relation, the whole world, like how things move, what are like what how the cosmos is moving up there. Look, as I told you, it's very heavy, and I cannot like, talk about it right now, my brother. We need to talk about more simple stuff here. So don't talk about the cause, like the reasons. We should only talk about the causes and effects, not the reasons, like what is causing that. We can see the effects. And I told you some effects. One of them was the rotation of the stars, one in north, one in south. And I told you how things below these two celestial sphere would have moved in the other direction, the opposite direction. And I gave you the third law of Newton. Like if you sit in a car, once the car starts moving forward, you're gonna feel that you're going backwards, right? So if you have a bias up there that is going clockwise, things on the ground goes counterclockwise. Now that's all I can tell you right now, my brother. That's all I can tell you. Just look at the signs, look
Well,
at the
okay, just
symptoms, look at
you're gonna waffle on the question. That's fine. I hope you sound like a reasonably smart guy. I hope this is just a troll. You know, I pretended to be a flat earther for 2 years. I hope it's just a troll and that you don't actually believe in the flat Earth. But that's actually a compliment.
no. I'm not a like those. Like, I believe in a different type of a flat Earth. It's not like it's not common. But I don't believe in globe like because of the the argument that we had before, like a couple minutes before about the spinning thing. And I think you have to admit it that you didn't have a good answer. And it's not about you. A lot of my professors, a lot of people science people that I spoke with them, they don't have a good answer for this, like how the helicopter or high altitude balloon remains in the same position. They don't have it. So definitely, I'm not a glober, but even this a flat Earth model that most of flat Earthers believe in today, yeah, even that has a lot of problem with it. But it doesn't mean that the globe model is correct, my brother. And I'm not messing around with you. I don't want to, trolling you here. But your question that how that force in the the cosmos would be converted on the ground. Well, my brother, this is a very you got to admit it. This is a very heavy question, and it's not something I can answer it very fast. It requires days, and it requires a lot of other things.
No, it requires
Please,
experimentation and
yes.
observation. You'd have to show me the experiment that you've conducted to demonstrate that this is something real. And if you guys don't have that experiment, which so far, look, I've been in the flat Earth community since 2016. I've never seen a paper on this. I'm assuming nobody has it. Am I
Newton's
right or am I
bucket,
wrong?
Mach's principle. Come on now.
No, we're
There's a
specifically
one
talking
paper.
about the
There's a
inertial
one
sky.
paper that we want to publish. We're going to publish our paper in the archive. Let me just tell you, we don't have a platform. We don't have a legitimated There is no platform for flat earthers in the world that they can publish their papers. You need to understand that even if
It's
we
not
flat
published.
earthers, even if we would have come up with the best paper, you need to understand once the fucking paper goes into the jury, it will be immediately they will reject it. Because in the first place, we're going to say that the Earth is not a globe, and the community is not going to accept any paper. So this is a very naive and simple question. If you say that why flat Earthers they don't have a paper, you're talking about the greatest conspiracy in the world, and you want paper based on it, my brother. What are you talking about? No, we don't have papers. I'm sorry, but as I told you, we're hoping to have our first paper next year, probably listed next year on Archive, because Archive is a free platform and everyone can have their own papers, and it's more like I think it's more like an open thing compared to the other platforms. Though it's not very professional, but it's something that you can later refer to it if you want to talk about something. Yeah, we don't have papers. We don't have schools. No, we don't have. And just because of these things, you cannot say it's wrong. But what
You
we
don't hold
had
the same
before.
standard for your own model, dude. You're asking what is the force that's acting on the what's causing sidereal rotation? You guys say that space time is acting on like everything.
No,
How did you identify
nobody
space
says
time?
that.
Yes,
The
Wait,
everybody
you're
sidereal
says
asking
that,
rotation.
and
why is it
yes,
spinning?
The Earth is spinning because it inherited the inertia from when the solar system formed.
how do you know that? You don't
Because
exactly.
we've modeled it. We've modeled it,
Oh,
We
and
so you
we
have a
modeled it.
model.
understand.
All
And we
Well, your
systems
under and
model
we
is
spinning.
under and we
reality now
under
because you made a
and we
model. Now your model becomes reality for no good reason.
consistent with our observations.
That doesn't make it reality.
So we could just, yeah, you could just say it's spinning because the universe is spinning, and that's what we observe.
I made a model. My model spins, therefore everything else spins. That's not a reasonable conclusion to come to.
Well, I mean, I think it's a little bit better than the flat Earth explanation for what created the flat Earth, right? Which is just God made it, right?
How?
How did the flat Earth become formed? How did mountains and valleys come into existence from the flat Earth?
Right, God created it.
Yeah, that's a great explanation.
If you believe in
So
the
good.
heliocentric model, I mean, it's way more plausible that God created the heliocentric model. Like, you have to believe in God if you believe in the heliocentric model. All the
What gives space
coincidences
and matter
and
in it? But
like, come on.
what gives space and matter the properties to make your accretion? Why is there such thing as accretion? You need God no matter what, dude.
You just don't like God or something?
No,
Yeah,
I'm just
this is
saying
about
it's
your
just not
dislike of the
it
creator.
doesn't have particularly good explanatory powers.
So the Big Bang is better than God. A random explosion from nothingness. Nothingness is better than God.
Yeah, you
I
guys
don't
say
think anybody
matter. You
nobody
guys
says
say
it's from
inanimate
nothing.
matter is sentient.
Well, you said we're spinning because it came from, how the universe was created,
The
which is
solar
the big,
system was
and your
created.
model is the Big Bang. I don't know if you have any theories, but some things in the world we just can't explain. Science can't even explain it.
Yeah, I mean, yeah, sure. If you get to the extremes of anybody's knowledge, right, you get to the unexplained.
Well, you said that's the whole reason it's spinning, and we could model it and this and
Oh
that.
yeah, the
Like
solar
we
system.
could just
Yeah,
we can
the reason why the
how
Earth
fast
rotates.
the Earth
Sure.
rotates, and we could make a model for anything. We could say a potato a billion light years away exploded and it created this spin, and we can model the potato exploding and all this other random stuff, and we can model it. It doesn't mean it's true. We just have to go off what we can observe and what we can test.
Kasra, I'm curious because you sound like you have a slightly different perspective than more traditional flat Earth perspective. Are you also of the all of space technology is fake and that all pictures from space are fake? Are you in that camp as well? All pictures and video from space is fake.
Yeah, yeah. I don't believe in. I believe in aeronautics because I'm an aerospace engineer. I know it sounds crazy. I know it sounds, ironic, but I have masters in aerospace engineering. I graduated 2012 in University of Leicester. I wasn't a flat earther till I started observing some of these, these long distance objects like, Chicago skylines and Michigan. Yeah, Chicago. I think it was Toronto skyline. So yeah, I gradually turned to a flat earther, and now regarding to your question, I can say that I believe in aeronautics, I believe in avionics, I believe in airplanes, helicopters, but I do not believe in James Webb or space industry. Yeah,
What about the ISS? Do you think there's an object
I don't.
300,
No, 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 no,
250
even not,
miles up?
even not.
Huh?
Well, I give you a very simple clue that it will rules out the ISS in your mind. If you look at the ISS, many times you can see there's an astronaut is having a spacewalk around the ISS, for fixing some of the parts and whatever. Based on physics, those two objects, you need to understand the ISS is 1,000 times heavier than an individual astronaut. They cannot move with the same velocity, with a different mass in the same orbit. That's for sure. It's impossible because the centrifugal force and the gravity are so different between these two objects. So an astronaut cannot stay
Dude,
or stand next to an ISS with 40,000 kilometers per hour. But yeah, I don't believe in ISS. I don't believe in James Webb. I don't believe moon landing. I think that is the most
but people
important.
see like I've seen the ISS lots of times. Uh, I've looked at it. I've looked at it through my 8-inch Sobsonian. It's tough to track it though. But we have people like Astronomy Live that wrote software for his mount that will track it really smoothly. We've got some great high res video and pictures that he's taken. He even invited the flat earthers to come during an ISS pass. So we
Has he
know that
seen an
that. So we
astronaut?
know. So we know
Has he
that. So
seen an
we know.
astronaut on
Hold on,
there?
hold on. This is for Kasra, if you don't mind. So
You're in a
Kasra, we
public
know we know
setting.
that we know that there's an object up there that looks like the ISS, and because we can independently triangulate its altitude and we can independently track its velocity, we know that the object is of the size. We know that the object is of the physical size that's claimed. So, what is the flat Earth explanation? You're an aeronautical engineer, so how do you explain this
So
object
I'll tell you.
that is
So
as large as a football field that's traveling
yeah.
250 miles above the Earth at 17,000 miles per hour? What is the flat Earth explanation for that object?
Yeah, so basically, there's something up there. I've seen it by myself. Those images from ISS. Though it's very hard to track it by yourself. I have a good telescope. I have a automatic mounts as well, but for me it was very hard to track the ISS. Though I have a very clear sky here, but I've seen on some YouTubes that people have done it, and there's you can see a blur vision of the ISS that is moving across the sky. That's for sure. That's something that we can acknowledge, but what you say right now that we can use trigonometry to find the height of ISS. I think that this is incorrect, and that's not true. And if you think that's true, why don't you share the thing with us so that we can educate ourselves with it?
Okay, so a few years back, the ISS made a pass that went between. I had a friend in San Francisco as another Glober on the server, and I'm in Los Angeles, and the ISS pass. It made a pass between us, and we're a known distance apart. And what we did is we used the Theodolite app on our phone, which will show you the angle of elevation of the object. It also will print the GPS coordinate and exact time on the picture. So that, and we just took a bunch of pictures when it was passing over, and we found pictures where the times matched. And we looked at the angle of elevation, right, which is the angle where obviously if you point it straight up, the phone on its face on the ground, it's going to be 90 degrees. If you put it perpendicular, the angle is going to be 0, right? So you get this angle that's between the two observers, and now we have a triangle, right? We've got a base with a known length, and we have two angles on opposite ends. I'm sure you learned trigonometry as part of your education, did you not? Why aren't we able to then independently know what the altitude is?
Okay. Okay, we did it. Did you know that we use the same technique for calculating the height of the sun and the rest of the things? And if you do
No,
that,
you
you're not
can't.
going
You
to.
cannot use that technique for the sun because our baseline is not large enough for the distance given.
Who told you that? Let me just give you a very simple example. Coastline of America, West Coast, East Coast, 3,000 miles, 3 hours difference. Now, let's say one observer is in New York, the other observer is in San Diego. One would be 3 o'clock, the other one would be 12 o'clock at noon. Now, if you look at, you can make a right
Yeah,
triangle over there.
yeah,
Yeah,
but that would be over such a
bro,
large
listen.
distance. Now we're talking about. Now we've got it.
No,
Sorry,
no,
go
no.
ahead.
You're saying for sun it's impossible. I'm telling you, for sun it's possible. So, so let's say in New York, the sun, let's say San Diego is right above you, and New York is 45 degrees in the sky. So all you have to do, you have to multiply the tangent of 45 degrees to the base of your triangle. You're gonna get the height of the triangle. My brother, this is the thing
But
that
now we're
we
talking
do,
about. First
and
of
you're
all,
trying
now
to teach us.
we're talking
This is
about it.
our method.
We're talking about it. We're
Bro,
talking
this
about a
is
3,000 mile. We're talking about a 3,000 mile baseline on an object
yeah.
that's 80 to 100 million miles away, right?
Told you
How
that.
accurate? How accurate does your angle measurement have to be to get
It
your
doesn't matter.
accurate distance? If you have a
Bro, listen,
triangle that's 3,000 on, you have a triangle that's 3,000 on where your parallax difference is 3,000 versus 100 million. How accurate does that
how
angle
is that
measurement have to be?
possible? This is the thing. You're just
That's
giving the
why.
answer to
That's why.
you just
That's
gave me the
why.
answer to your dumb question. How is it possible a triangle which has a base about 3,000
By the way,
miles would have a fuck? Bro, listen? You're not paying attention what you're asking me. You know that the base of the triangle is about 3,000 miles, and you know that your theodolites is going to measure about 45 degrees, 60 degrees. It doesn't matter. Listen, it doesn't
we're not
matter.
talking about. We're
Any
not talking
angle.
about a
Bro,
parallax measurement that's outside of our. We're not
this is
talking
not
about. We're
parallax.
not talking about
You're
a
not,
parallax. We're not
Nobody's been
talking.
talking about parallax. Why are you doing this? Nobody's been. Did I talk about guys? Did I talk about parallax here? No. I said 2 points on the ground, and the distance between 2 points. You're gonna have the base. You're gonna have two angles. You're gonna solve trigonometry. That's cool. We understand that, and I'm telling you, Based on what you said right now, it would be impossible to have a triangle
Okay,
with these numbers
but
that
why
you've
is it
given to us.
why is it impossible on the ISS to do it this way? Can you explain why?
Because okay, do it, bro. Do it with your numbers.
Why
You're
is it
not gonna get that.
impossible?
What is
We're talking about we're talking
four
about we're talking about
kilometers?
we're talking
It is
about a
400.
baseline that's we're talking about a bit we're talking about very measurable. We're talking about unlike the other example where it's way outside of our
Mhm,
ability to measure the angle accurately, right?
mhm.
A 3,000 mile baseline versus 80 million miles. We're talking about 250 miles versus 350 mile separation for the baseline, right? So now we're talking about like, oh well,
For
that's
ISS, it
well,
might make sense. Yeah, yeah, yeah,
even if our angle
yeah,
measurement is off by 5 degrees, we get a pretty reasonable
yeah, yeah,
ballpark of its altitude, even if we're off by five
yeah,
degrees, right? Whereas in
yeah.
the other example, I don't know how many decimal places of angle accuracy we do. I'd have to work out the math on it. It's probably
Doesn't
like
matter.
10
Decimals.
decimal,
Leave the
10,
decimals, bro.
10
Leave the
decimal.
decimals. Don't
We
leave
need to
decimals.
measure the sun's position within probably 9 or 10 decimal places of angle, right?
No, you don't need that. You don't need to get that much accurate there. All you need to just 4 digits is enough. You don't listen.
Hold on,
Okay.
hold on. If we're trying to determine, if we're talking about, we have a 3,000 mile baseline, and we're trying to calculate the height of a triangle with a 3,000 mile base,
Mm-hmm,
with 3,000 mile
mm-hmm.
base, and then the tip of the triangle is 100 million versus that 3,000. What's going to be? What are those angles going to be?
It's gonna be fucking so
Well,
small. It's gonna be fucking hilarious. It's not gonna. Yeah, this is the point. You just made it right now.
that's going to
If
be
you would have a
outside of your ability
3,000
to.
page,
Okay, but here's the thing. We both agree that's going to require an extreme amount of precision to measure that
no, no, no,
angular.
no, no, no. Because bro, the height of the triangle that you're claiming based on this method, it would be about 150 million miles or 90 million miles away. Look, your sun is 90 million miles away. So you're
Right.
saying based. This is the thing. So
But how does
listen,
that have to do? What
listen.
does that have to do with the ISS, where it's only 250 miles and there's a 350
Okay,
mile
okay,
baseline? Why
okay. I'm
why
sorry.
doesn't the
I'm
math work
sorry.
for
Okay,
that? Why do you
I'm
keep going
sorry.
back
Let
to
me
the
just correct
sun?
myself. Let me just correct myself. Okay, let me just correct myself. The method that we just spoke right now is so valid. It's not parallax. It's the method that we flat earthers we have used for calculating the distance of the sun and moon, and we're gonna get these numbers. We don't have any argument about that. Now you're telling me, but what about the ISS? To be honest, bro, I'm not a liar. I never tried it with ISS, but I think for ISS, and based on what you're saying to me, I think we would get it 400 kilometers accurately because if the base of the triangle would be 3,000 miles, let's say it cold the whole width of the United States, coast to coast, right? Now,
But you can't see the ISS. You can't see the ISS from coast to coast at the same time.
I don't know. Look, I don't know. Bro,
There's
I
only
don't know
about
the
a nine.
exact number.
There's about a 900 mile radius around the ISS. Not even 900
900 miles.
miles.
Okay,
I think it's like
so
yeah, I think it's 900 miles if I'm not
okay,
mistaken. But
so I would have advocate you for myself. Like you can do it on behalf of myself. I trust you.
okay, okay,
So you're
okay.
saying that. So you're saying
So
that.
we
Okay, okay.
know
So you're yeah. Hold on. So you're saying that you and your friend you were across from 3,000 miles, let's for example, and you guys have
350 miles.
350 miles, and you guys have some theodolites, and you have found the angular
And we're
height, and you just
measuring
put in
the angle
geometry.
because the past happened
Yeah,
between me
yeah.
and him.
And you
So the
found the
ISS
height
was
of the triangle. Yeah, and you guys have found the height of the triangle, and that turns to be LB 400 kilometers, which was accurate. Is that what you're saying here?
that's right. And because we know how long it
Okay,
takes to
bro.
go
Okay,
from being
bro. Okay, bro.
directly,
Listen
and
to me.
because we know
Listen
how
to me.
long it takes to
If
go
you know
from
that the
one
base
zenith
of
to
the
another,
triangle.
we can also independently calculate its speed.
Okay, I got your point. You're right about it. Okay, so I want everyone to listen, pay attention to what we say right now. So our friend Jake is saying that he has used this method point to point. He made he triangulated 3 points, and he used two angles and one side to solve the triangle. Right? This is what we do in science, and he did it, and he came up with 400 kilometers. by yourself, and I wanted to just say it by your own mouth that the method that you have used was a Euclidean method. Was a triangle with straight lines, and the base was straight. And this is what we're telling you. And this is what we're telling you basically. That we can use this method as long as the flat surface is available, and we assume that it's a flat surface. We can use this very simple trigonometry method to do whatever we want, to find the distance, to find the velocity, and everything. But you need to understand on the globe model, you guys are not allowed to do this because you have to use parallax. You have to use presumptions. You got to use a lot of shit in your calculations. And if you don't believe in me, do it by yourself.
I have a dumb question. I'm not the best at math, but couldn't the ISS be a lot closer and a lot smaller? Would you get the same measurements, or a lot farther away and a lot bigger?
No, the size of the ISS is irrelevant in this.
Well, the
And
size
and
that they
and, and
gave you, are you using that size in your calculation? You're plugging it
no,
in
the size of
or
the
not?
ISS is irrelevant. It could be a point source of light. It doesn't matter.
Okay.
But sorry, I disconnected. My connection dropped off, so I didn't hear most of that. But even if we were to, if we assume a flat Earth, or we assume the amount of curvature over 350 miles with the object passing between us, which is only like 175 miles, the amount that assuming a globe Earth, a curved surface globe Earth versus a flat Earth would only change it by a few miles. There wouldn't be a big difference in terms of its
Exactly. Now,
elevation
if
over
you
the flat
include
Earth.
the base,
We still know
yeah,
that it's
you're right
way,
about
way,
it.
way higher than we still know that it's way, 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 way higher than any airplane.
Okay, so you're saying okay, that was a good. I don't know where that I cut off. I don't know how many of you guys have heard what I said, but I said that you use a flat surface to do your method. But now you're not. Now your new claim is that since these 2 points are kind of close to each other, and the curved line and the straight line, they're not going to be lot more different. I'm going to get a good answer, and I'm still going to say, yeah, you're right. You're good. Okay, you're good as long as these 2 points are close. What if I start moving these 2 points from each other? What you gonna do over
Wait,
there?
wait, wait,
If
wait.
I
What
put one
what
up,
2 points though? What are you talking about?
if I put one up, if I look, if I put 1 point in Asia and one point in America, you cannot assume that this is a straight line anymore, and
Okay,
you cannot use
but that's not the
trigonometry.
observation that we made, and you wouldn't be able to see the ISS
Now
over
I
that
don't care
distance
about your
anyway. So
observation, bro. I'm talking generally
okay,
here.
so let's go
I
back
know
to the
you.
ISS because you're because I specifically
No,
want to
I'm
ask
talking
you about
about
this because
ISS. I'm talking about ISS.
you're an aeronautical engineer. We know that this object is 400 kilometers up, and we know it's traveling at 17,000 miles per hour.
No, no, I know
What
that, Ed, but I was trying to
Okay,
tell you
okay.
that, and
So,
you have
so,
used
and
a
we
flat
also,
surface.
and because we know all that, we know that it's the size of a football field, and we know that it looks like a man-made object. It doesn't look like some mysterious, natural phenomenon. We know it
So
looks like a
what,
man-made
bro? So
object.
what? What do you want to prove here,
So,
bro?
so, so what's since you being an aeronautical engineer, you got a master's degree in aeronautics. What could that possibly be that can be
A
up there
machine, a
for
machine,
decades? What could that? Okay, but
a machine.
under what aeronautical principle is it able to maintain that speed and velocity over the flat Earth if it's not in orbit? You're an aeronautical engineer. You're the best person in all of flat Earth.
You're not asking. Okay,
Probably
you're
you're,
not
and I'll
asking
tell
any.
you
Okay,
and I'll tell you right now, Kara. In all my years of talking to flat earthers, you are the first master's degree holding aeronautical engineer I've ever run into the flat Earth. So you are
no,
uniquely
I got
capable of
friends.
answering this question.
Okay, so your questions are getting so wild. And can you understand that you're
Wait,
asking
wait,
very
wait,
wild
wait.
questions?
Asking how the ISS works using flat Earth theory and known aeronautical
I don't
knowledge
know whether
is not a wild
okay, bro.
question.
We
It is
don't know.
not a wild question, bro. It really
No,
isn't.
we don't know about the ISS, brother. We don't know. Okay, we can
Okay, but
see it.
you're an
We
art.
can.
You've learned all the
It's
technology that they
it's
teach
not
to build stuff,
falsifiable. We
right?
can't go up there and test
Kara,
it.
Kara,
Nobody
you
like.
have learned all the
Okay.
knowledge that we teach all other engineers on how to build stuff. So you would have learned the knowledge of how to make this object work on a flat Earth. So please explain to me what engineering principles are applied to let this thing fly around for years at that speed and velocity
On the flat Earth, right? On the flat Earth.
on a
You want
flat
to
Earth.
ask
Yes,
about? You're
yes.
asking the
You told
deepest
me.
question. No, bro. I told you before. We're not gonna do this for flat Earth here right now for you, my brother.
Okay, so
Look,
you're going to
I'm not
waffle
gonna
on this
make
question
myself
too.
the risk
You're
of
going to
it.
waffle. So you're going to waffle on this question. You told me you have good reasons for believing in the flat Earth. I believe in good faith
I'm
that you
just
came
here
to me
for
and
you to
said
debunk
that
your model.
you told me that despite all your aeronautical knowledge, getting your master's degree in aeronautics, that you have a good reason to believe in the flat Earth. So here we go. We have a real world object that you have to try to figure out now how to explain within your worldview, and you have all the knowledge about aeronautics. You're uniquely qualified to determine whether this is bullshit or not bullshit. So now you have to explain away in orbit, right? You have to figure out how this object travels. Number one, why does it travel the path that it does, and why do all observers along that path see it at that time? And then you have to figure
Yeah,
out
you're
what is
right
it,
about
what is propelling it over the flat Earth, and you have no explanation, and you wouldn't even have, you can't even theorize a mechanism by which you could explain it, right?
How
It's
do you
in
know
the
that you don't
lower
have
level of the firmament,
I don't want to get into this,
fluid
right?
dynamics.
I can get into the cosmic flow. I can get into a lot of things, but I don't want to do it, guys. It's not right for him right now.
But Jake, didn't you just debunk globe Earth by you just admitted you used the flat baseline for your trigonometry
I
over
simply
300
said
miles apart
that
to be
over such a
curved, right?
short distance, using a flat
That's not
baseline
a
to make
short
math,
distance. There's significant curve over
150
300
miles.
miles.
How much drop is there? 150 miles.
You said 300.
The object was halfway between us, right? We were 350 miles apart. It was roughly halfway between us, roughly 150 to 175 miles between the two observers. How much drop is there from the observer to the object?
Uh, I would say under a mile, maybe around a mile. I don't know.
But
Really,
Jake, I don't
things
know
can't
what.
fly on the flat Earth. I don't know what you think is going on, dude.
It's like 3 miles. It's like 15,000 feet of drop.
Why
So
can't
so
fly on the
so
flat Earth? What
if
are
we
you
did if
saying
we
is stopping things from maintaining a flight?
well, we would have to explain some way that it's able to stay aloft and not fall because of density and
They
buoyancy,
refuel
right?
the ISS all the time. They got a Dragon capsule that docks to it. The ISS has thrusters on.
Okay, okay, but how? Okay, but
You're saying that the ISS
it's
doesn't
way
have
above
to
the
thrust,
hold on.
but it's getting refueled every.
It's way above the atmosphere, so you cannot use aerodynamic lift. Which then the only way you'd be able to keep it aloft would be using some kind of rocket
Oh, cool. So rockets
propulsion.
propel in a vacuum too, so not an issue.
Okay, but I mean, you're burning. I mean, for something the mass of the ISS, how much propellant would you be going through to maintain its altitude over the
Rockets
flat
don't
Earth?
have to have air to propel either.
I didn't say that.
I
I
have
said if
propulsion.
we if it would have to be propel, it would have to constantly be propelled because orbits are impossible on a flat Earth. It would
You
have to
don't
be
require
constantly.
air to
It
be
would
in
have to.
flight.
I understand that, but it would have to constantly be thrusting. It would have to be constantly thrusting its way
Yeah,
around the flat Earth, and it would be doing that every day for decades on end.
Put something
You know,
combustible in
we
your
know how fast
chamber. Boom, you're
we know
done.
how
if you
many
hover a
decades?
rocket,
When you say
we
on end, how many decades do you mean? You talking about 4?
well, it's been up there since they started building it in the 90s, right? So we're talking at
Oh,
least 2 decades now, going on to
What
three.
what do you
yeah,
think?
It'll
on
get
end.
decommissioned on the 33rd year.
It's supposed to be decommissioned, probably because it's too expensive.
On the
Okay, it
33rd
is
year, it'll be
expensive. There's no
decommissioned.
argument there. But the question is, how is it being propelled on the flat Earth? You can't say that it's rockets because number one, we don't see any signs of rockets on it. We also don't see, we also
Okay,
know how much,
let me give you a very simple. Let me give you a very
we can
simple answer.
also calculate.
Jake. Simple answer. Simple answer. Okay, how does a boat flows or sails on an ocean? Do you agree it's a free ride?
Are we talking about a sailboat?
No,
He
not a
asked you a
sailboat. Like
question.
even without a what do you call nothing?
Sail?
Just a boat, just a fucking boat without anything, without any
Well, then
propulsion system.
it's just gonna be carried by whatever the currents are, right? It's just gonna
Exactly. So
it's
there's
gonna
a
bob around
main
with whatever the
current.
ocean currents are.
It's like a river. If you go in the river, you don't need a propulsion system. It just goes by itself, right?
I
The
definitely
reason that
get
I
a
told you
rudder.
I don't want to open this shit up right now because we flat earthers, we believe in cosmic water. We believe that there's a flow up there that it goes, that it's carrying not only the things, it carries the moon, sun, and rest of the thing with itself. There is a free ride, there is a free energy up there that the system is using that.
I wouldn't
That's all it
even.
is.
So, so
I,
let me ask
hold
you
on.
one last question, Castro, and this is a serious question. I'm gonna ask you one last question. It's not a gotcha at all either. So you would then have to imagine, and you would agree with me, that that would mean that teams of engineers like yourself that went to school and studied all this stuff would basically then have to be told, you're going to go to this other school where you're going to learn a bunch of engineering and science that they don't teach you in schools. They're going to teach you about, okay, you know what? We live on a flat Earth. It's all a lie. You don't live on a globe. Orbits are impossible. You
No, that's
actually,
not the
would you,
case.
No.
hold on. Let me just finish. Let
It
me just get
doesn't
this out. Let
follow
me just get
because
Oh,
this
it
out.
could
you're
be
scattergunning
identical.
straw
Let me
man
just get
right
this
It
now.
could
out.
be
Can I just get
Non
this
identical.
out?
sequitur.
Can I
Yeah,
please just
Jake,
get this out? This is for
you'd be
Kasra.
straw manning the whole room to
No,
say
no, 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 no.
anything like that because
No,
Yep.
everything that you're saying is
I just
based
want
off
a
the
serious answer to this question. I don't know why you guys are trying to keep me from talking.
It's
I
not
just
a
want to.
everything you're
serious.
This is
Hold
a
saying is
on.
question for
based off of
Kasra
the
because
premise.
Kasra has a unique position here. So
It's
But
not
you're
a
engineers
saying
like
that we
yourself,
keep you from
God, why do
talking,
you
but
guys
you
have to
either
prevent me from talking?
Jake. Here's the reason. It's because it's not a serious question. It's a question
It
from
is. It is a
incongruity,
serious
meaning
question
that, hey,
because
let me finish
Kasra.
my statement.
No, you guys interrupted me.
Meaning
I
that
was talking.
meaning meaning that it is a question from incongruity. You're trying to claim what the fuck?
oh, he left. He started to yell as you were talking, so I was gonna mute him until you were done, and then he could go.
I mean, y'all
But
fucking stop him from talking. What the
Yo,
fuck is that?
I just wanna say, yo, Kasra, that was
Yeah,
excellent. Well said, dude.
that's so hypocritical,
Well,
man.
here's the thing. He asked the question, but then continued to talk. He said, "You're going to have to show me this new school of people going to this new blah blah blah." And then the question was trying to be answered, but then he continued to talk over.
right,
That
you
was
would
the
just
problem.
bulldoze over people and try to move on to a new point.
Yep.
But we did want to answer,
When,
though. I mean, but if you say, "Here's my question," and then all these engineers also would have to go to a different school where they're told that it's actually, and then he started to like straw man the answer that hadn't yet been said.
exactly.
Yeah,
And
well, I
that's
mean,
the thing is there's a million different answers that we don't need to change physics. We don't need to change whatever. You just need to change the conception of what he presupposes the environment is up there,
yeah,
right?
but I
And what
mean,
he presupposes is taking place.
Carson. I mean, I came in at the end of Carson's statement, but he made some weird claim about all flat earthers believe about this cosmic water. I'm not sure what he's talking about.
Yeah, he did say
I
we.
didn't. I
That
was
was kind of
giving him
weird.
a very simple short answer, to be honest. Like I know, like some of you guys might not believe me too. Even I'm not sure about it, but he was. I keep asking this dumb question, so I'll have to give him an answer. But I think that was a good one. I still believe in that. When I see oceans and rivers, I can see that free flow. So why not having the same shit up there as above, so
Yeah.
below, law of correspondence, right?
Yeah.
So
There's
that much
It wasn't
different.
that
There's a
bad. I
million.
mean, you said we flat earthers all believe in like this cosmic water or flow, which I guess would have to, right? Because if not, then we'd have to be appealing to nothing, which would be like a vacuum of space.
No,
Yeah.
there's a bunch of different answers, right? And yeah, I would caution against just trying to throw everybody into the same group and say we all believe this or we all believe that because if there's one thing I've learned being in the community, it's that not everybody has the same agreements and conclusions. That's what sets us apart from the Globers who have to follow a script, have to have certain beliefs. They can't go off of that, right? We have many different ideas and conceptions, some of which have been proven out, some are just purely speculation, some are logical inferences, right? So there are a bunch of different possibilities as to what could be taking place up there, right? If you were talking about like this cosmic water or whatever you want to talk about, if we live in a magnetic field, who's to say that the same way that we have magnetic levitation when you're on the, you know, close to the edge of opposing magnetic fields, what's to say that the energies up there couldn't have something similar? And then you have, you know, this almost like zero resistance that could hold something in place moving around in a magnetic fashion, right, with levitation. So there's a million different ways, and that's just one.
Yeah, and no thanks. That was a false dichotomy. No thanks. Trying to say if it's not water, then it'll just be empty. It'll be a vacuum or some shit like that.
Yeah, well, not water, but like cosmic flow of current of something, or not, which would be nothing.
I think
I think the cosmic water was just like a term, like
yeah, well,
a
that's kind of a false dichotomy, right? Because it could be a liquid, it could be some type of like superfluid, it could be something that is still, adhering to the normal like fluid dynamics, or it could be something like I proposed, right? I think there's a ton of different possibilities. The problem is when you have somebody that has to infer based on his presupposed positions, and then you have to come into his realm on his presuppositions to explain it. You're never going to get too far because he can't get outside of his presuppositions.
yeah. Kasra had a lot of good arguments with the the helicopter, etc. I wouldn't get on you about the. I don't know what else would you call it? Cosmic something. I don't know what some kind of word. I don't know what
Just
word
more
we
fluid.
use.
I mean,
What
just more fluid. It'll be another fluid substance.
what if it's just a magnetic field? Like I said before, when you have magnets, when you play with magnets, you can almost feel that magnetic field as you feel the opposition from magnets when they oppose one another. What are you feeling there? Is that a fluid? It feels fluid like, but it's not a fluid.
Uh-huh.
I guess my question to y'all would be like, what is the ISS flying through? Because it would have
Fluid?
to be outside of the atmosphere, right?
No, why would it?
No, the atmosphere goes all the way to the moon. So even in your conception of your worldview, what do you mean it's outside of the atmosphere?
No, the atmosphere. The atmosphere doesn't go all the way to the moon. Why do y'all say that?
Because
It
that's what
doesn't
they
go.
say.
That's what
That's
NASA
No,
says. Do you disagree
no.
with NASA?
NASA's not saying that though. NASA's saying that
yeah,
there's
it is.
particles of the
Yeah, they do.
atmosphere to the moon. No, that's like me. We've been over this before. That'd be like me saying, "Oh, it's a grain of sand all the way over here, so the beach stretches all the way over." No, all they're saying is particles of the atmosphere can be found past the moon.
Wait, you don't think the beach stretches to where you are?
A piece of sand from.
No.
So if you find one grain of sand from the beach,
No,
you're on the
you just
beach.
go ahead and dig down. Do you find water? You got
I
all
mean,
the
I'm sure.
elements right
I'm
there.
sure. I'm sure if you dug down, you can find water. But what I'm saying is, like, you get what I'm saying? Like, you're on the fucking beach. We know what a beach is. A grain of sand from that beach is like all the way on the other side of the city, and you're saying, "Oh, I found one grain of sand here, so the beach is
Well,
all the way
that's
over here too."
like think about an
But
island, right? A small island, right? You like Hawaii. You got beaches around the outside and mountains in the middle. And then you're saying if you're up on the mountain, you're not going to say you're on the beach. But
Right.
but either way, his question's nonsense. Outside the atmosphere, what does that have any relevance at all?
Because it would have to be the shape of the ISS. So we all know how the ISS look. If the ISS was flying through the atmosphere, then it would
Who
I
made
mean
that
basically
claim?
it would disintegrate.
Did anybody say that the ISS is flying within a certain amount of atmosphere?
Well, that's why I asked. I was saying like that the ISS would have to be flying outside of it then, right?
No, NASA claims that the ISS is inside Earth's atmosphere because they say the moon is in Earth's
Yeah.
atmosphere and the ISS is in between the moon and Earth. So
That's not what NASA says.
Low Earth
NASA does
orbit is
say
still.
I've actually used this as an argument before. There's citations from NASA saying the moon is in Earth's orbit. So if NASA says the moon is in Earth's orbit, clearly the ISS must be in Earth's atmosphere.
The moon is in and what's all right, but the moon is definitely within Earth's orbit. Is it within
No,
the
I meant to
atmosphere?
say
No.
Earth's atmosphere. I meant to say the moon
Oh,
is
okay.
within Earth's
Sorry.
atmosphere.
Oh, I
NASA says
apologize.
that the moon is in Earth's atmosphere.
No,
Earth's
there's no.
atmosphere stretches
They
out
literally
to the
do.
moon
I'll
and
get you the
beyond.
citation.
I got it for
I'll
you.
get you
I
the
got it.
citation. You got it.
I got it. I got it. Earth's atmosphere
Thank you.
stretches out to the moon and beyond.
Yes,
There we
Yeah,
go.
particles
just
of
So
atmosphere.
obviously now knowing that, right? The obviously the ISS must be within Earth's atmosphere, right?
Oh my God, you're. I see what you're doing. I mean,
We're going
Well,
off
where does
NASA,
I feel
bro.
Earth's
like
That's
y'all
what
doing
I'm
this.
doing.
I feel like y'all doing
I'm
where
this on
does
literally
Earth's
purpose.
atmosphere
I
end,
feel like y'all doing
Carlito?
this. I
what
feel like
I'm
y'all doing
doing,
this on purpose.
Carl. What I'm doing is I'm going off when I'm steel manning NASA. That's what I'm doing. We're steel manning NASA's claims.
No, so what NASA means is there's particles of the atmosphere that stretch to the moon, right? Which would you would consider that
No.
the exosphere, I guess. I think that's
They call it a whole
the
layer.
exosphere.
They call it an exosphere. It's a whole
Right. Yeah.
layer that extends past the moon.
Yeah. The exosphere. So if you want to use a technicality and say, well, you got one particle of Earth's atmosphere right here, therefore you consider this the exosphere.
No,
well,
Then
no,
They
the
don't say
There's
one
atmosphere is
more.
a
particle.
layered environment in the first place, right? We have the troposphere, the mesosphere. We have all of these are called the atmosphere. So now you're trying to make a claim that the exosphere is not within the atmosphere, which is just not true.
and anyway, it's just an arbitrary line to begin with. It's the Kármán line. Is that where you're saying it starts and ends?
I mean, I guess you can use the Karman line. Look, I'll concede that point just in the interest of time. I don't want to argue word semantics here. But basically,
Yeah,
what I'm
because
trying to get at,
if it's a gradient, right, and it's slowly reducing, even you say that there might be slight particles all the way to the moon. If it's this ever decreasing amount of gas pressure, right, then it's just an arbitrary line on what we would or would not call the atmosphere. So there's just different things that could be taking place. And if anything, this just makes our argument even better. It's like, cool. So we have way less air resistance, right? There was no height claim to where the ISS was in the conversation. Nobody made a claim that it was in the Earth's atmosphere. There was no specific height claim, and there was no refutation as to the height of the ISS. The question,
No,
the, the question is whether or not it could or could
NASA's
not
claiming.
function over a flat Earth.
NASA's claiming that the ISS is in Earth's atmosphere because NASA also claiming that the moon is in Earth's atmosphere.
I don't see why it couldn't
all
happen
right, like
over
I said,
flat Earth. I think you could have mass attracting mass and everything just the same way because you don't know the depth of the flat Earth and the field lines would become all vertical to one another. So it could all just work exactly the same.
Yeah, that's the thing. Like the dude was trying to basically, and this is the claim that like lots of times Zanuck will try to throw out there, but when he's kind of backed into a corner, is that, well, you're just going to have to completely rewrite physics, and there's going to be some sort of physics that everybody has to learn that nobody else knows that's being taught in secret, and blah blah blah. It's just this. It's a whole cop out for the actual argumentation.
Right, so yeah, he asked a question, then he started saying that all these engineers and people doing physics would have had to have been transported to this special super secret facility, and he was going to be this huge straw man why couldn't we just answer the question without him answering for us? Why couldn't people just answer the question? Why
He
does he have
wasn't
to
straw
answer with a
manning.
straw man?
No, he wasn't purposefully trying to strum. This is because this question is kind of a common question that most of the Globers would have said. I don't know if you guys have experienced this or not. They would have said that, okay, so you guys are saying that all the sciences are conspiracies, blah blah blah. Yeah, this is the first thing that it comes in their mind, and I understand that. Okay, I truly
Yeah.
understand that. But back to what we were saying about the this cosmic flow. Now, here's the thing that I personally have figured it out by myself, and I think that's kind of a little bit relevant here. If you look at the grading of the hardness and softness of our reality. If you look at the ground it's very hard, and the more you go down, the more you go below the earth, you're gonna hit more. Apart from the globe model that they're saying there's some lava magma under that, but we know that the more we go to the ground, we're gonna hit more harder materials, right?
Wait.
And
How do
once
you
you
know
come
that?
up, well, based on my own experience, like when I see the waters on the ground, I say that okay, the ground looks very firm, looks very hard to me because it's very hard to drill. But here's the thing: once you come up from the
Become the
ground,
fortune.
you're gonna reach the Yeah, once you come to the floor, you're gonna reach the waters like the oceans and the rivers that they kind of more softer. And as you move upward, you're gonna hit the atmosphere, which again is softer and lighter. So and we know by sure that we have plasma in our ionosphere. How do we know that? Because we are using the reflection of the ionosphere to transmit signals, right? This is what we are sure about. We flat earthers are pretty sure about this thing about the ionosphere, and ionosphere is plasma.
I'm
So
not sure
if you look
about
at
that.
the whole, but I'm so sure about it. I truly work with ionosphere. Ionosphere is truly works, and it's filled up with plasma. It
Yeah,
works like
but
a
hey,
reflector.
And
like
it's
we
a
said
globe
before,
shape.
No. It's not, bro.
but
Just
but like we
throw it
said
in the
before,
garbage.
don't pigeonhole people into being like, as flat earthers, we all know that the ionosphere. Like, why are you doing that? What you can say that you
Because
believe that the ionosphere is something that signals bounce off of, but why are you throwing everybody else into
let
that?
me just give you
Yeah,
my
make your
position. There's a
claim.
lot of
If you
things.
want to make your argument, make it for yourself. Take it on. Make it yours.
Yeah. So, but if I were you guys, I would have definitely listened to a person who has spent 8 years in university. And I do not believe in the globe model. I know Moonland is faking, it's fake, but I know a lot of things that flat earthers are rejecting. It's not rejectable, and it's true. One of them is the
Who
Curly
spent
effect.
8 years in university? Is
So,
that you?
He
this is
did,
apart
yeah.
from the conversation.
You did. Okay,
So,
you
So
spent
big.
so
eight
do
years
you
in
agree with
university.
Kasra? Do you
No,
agree
no,
with 69 miles per 1 degree?
yeah, of course. For Polaris, for Polaris.
Yeah.
Yeah, of course. That's a fucking thing that you can do it by yourself every day. You can do it and you can just verify it. It's pretty easy. Every 60 miles, just grab your theodolites, go just travel every 1 mile, every 69 or 110 kilometers or 69 miles. You're going to see a 1 degree drop.
Have you
That's for
done that?
sure. Yes, of course.
Oh, that's cool. How'd you set it up? I'm just wondering because I'm trying to set it up. I want to do it as
So
well.
you have to start moving. Where do you live?
I live in Florida. We have I-95, which is pretty
Oh, that's great.
straight
That's very
road.
good.
Yeah.
Exactly. Yeah. So start traveling to the north. Go to New York, for example, one day, and just measure
Well,
the
should I
angle of
take
the
the angle
Polaris.
measurement from where I am and then travel 69 miles north and then take another angle measurement?
Yeah, it's a linear relationship. If you plot the figure of height versus the angle, you're gonna see it's a linear relationship. The distance
Okay.
and the angular height. Yeah, that's
So
for
Okay.
fr-
sure. I'm telling
from
you. Yeah.
0 to 90.
Guys, please don't be silly. This is true.
Okay.
Come
So
on.
if that is
Yeah.
the case, Castro, real quick, I just want to run you through this. Do you know 69 times 90 would give us our radius, right?
69 pounds 90. Yeah. No,
Yeah.
if you assume that Earth is yeah, if you assume it's a circle, you can say
No,
that's
no,
the
but
radius.
in reality, we traveled 69 miles. We got 1 degree, and we know there's 90 degrees between the north and the equator. So now we have a radius value, right?
It's not a radius, it's a distance. This is your problem. You're just making a presumption. You're just doing the same thing that globers are doing it. And this is a flat earth presumption in your mind that you think this is a radius. We are not sure this is a radius.
I agree.
This is
We are
just a
not
distance.
sure. We are not sure that
Cool,
it is a
cool, cool,
radius. That's correct. So,
cool,
is it just a straight line? Is like the equator a circle or no?
Well, that's a different question. You want to move into this new one, but because you were saying that is that true every 69 miles at 1 degree? You were talking about that one. So let's stick into that one. So if you guys have problem with that, because I know that some of you guys don't believe in the 69 miles per degree
No, I'm fine
right
with
now. I don't
that. I
think
think that's something
you're
we
fine
can
with that.
test in reality. Yeah.
A lot of
Okay.
filler words. 8 years university. A lot of filler words.
I'm confused because I thought, the 69 per 1 mile relationship is only for a certain degree, in between a certain degrees.
Yeah, some people
No,
do
it's
say between 15 and 75 that relationship, but that's still, 69 times those 60 degrees gives you a number larger than 3959.
yeah, it's a linear relationship. As I said, it's going to be a straight line. If you draw the function of the angle versus the distance, you're going to see a straight line with 45 degree slope.
But how is it a
Oh,
linear relationship if it only works for a certain range of degrees within the 60 degrees?
Well, that would have to be
from zero,
checked. We would have to
you
check
have to,
that.
Well, it
yeah, you
can't
have to check
both
that
be
out.
a circle and a straight line. I know that.
So back to what I was trying to tell you guys. So here's the thing. This is what I think. I think that up there, it's a kind of a material that is lighter than air. It has to be either lighter than the air or even lighter than plasma. We don't know. This is the fourth state of matter, plasma, right? Or some people call it the first state because it's plasma, then gas, then liquids and solid, right? So the first state of matter, which is plasma, I think anything that is above plasma has to be lighter. Because if you look at the gradient of the softness and the density of the reality that we're living on it, as I said, it starts with earth, the dust and solid. Then you hit the oceans, which is liquid. Then you hit the gases, which is your atmosphere. Then you're gonna hit your plasma, which is super very tiny, super light gases. And above that, which we don't know when we're trying to postulate that, I can only give you two. I have only two opinion. One is that either it's glass type of a shit thing that we some of the flat Earth believe that might be true because I don't think that because even lighter than plasma, it's going to be vacuum. And if we don't believe in vacuums, therefore there should be a solid, very firm thing upon us, or there should be something even lighter than plasma, like I don't know. We can call it ether. We can call ether is everywhere. We can say it's just a pure luminiferous ether. And why
I
I'm
could
saying
give
is
you
that
a third
because
option there, Kasra. In your
okay, go on, go on, go on.
Yeah, your third option could be that the density gradient inverts at a certain height and starts going the other direction.
Oh, that was another one. Okay, okay. Like the moon. You want to say that like when we hit the moon, like moon is because like moon looks very hard. Don't you guys
All I'm
agree?
saying is once you reach the plasma and have to go into
Mhm.
the, what we don't know, what if it just starts going the exact opposite way, how it just was?
Opposite. Yeah,
Yeah.
yeah. I don't know. Yeah, that might be another option as well. Yeah, exactly. Yeah, for sure.
But yeah, go ahead. What were you saying about the luminiferous ether?
No, no, I don't want to right now. But I want to say that like that's something that and the reason I'm saying that it might be just pure luminiferous ether is because we can see the lights up there, right? The moon, sun. We know that they're pretty higher than the ionosphere, right? Ionosphere is not higher than 100, 200 kilometers, right? And these objects, based on the trigonometry that we flat earthers did, it's about the height of the cell shell are about 3,000, 4,000 miles. So I think that these phenomena are collapsing within the ether field up there. And the reason that and the only thing that is possible to observe is their light. Because ether is will only allow light to be glow within it. You know what I'm saying? Like it's the fabric of the light, it's the medium of the light. So I believe in that. I think that it has to be something with the luminous or ether up there. Yeah. And that is causing these
Yeah.
things to shine and we can see them through. Yeah, you know what I'm saying? So
Yeah,
that's it.
like if
So
everything needs a medium to travel through, light needs a medium to travel through, ether would be that medium light travels through. Is that what you're saying?
exactly. Yeah. So we don't have molecules up there, we don't have gas, but we still can have the ether, right? Because the light can travel within that thing, within that medium. And we can see it, right? We can see yeah.
Or
So
maybe light is ether, or the ether is light. Maybe that's how it works.
I don't know. I don't know. I don't think that light is ether. I think they're kind of different. Like because look at the waves, like the earthquake. Earthquake is a wave. The medium is earth. Tsunami. Tsunami is a wave. The medium is water. Voice. Voice is a wave. The medium is air. Uh, yeah. So light is a wave, and the medium has
No,
to be something, right?
no,
Yeah.
no, 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 no. You've got that all backwards, right? Because there's no such thing
Mhm.
as a wave without the water. So you're saying that light is
Mhm.
the wave. That is effectively saying that since light is a wave, what is waving you're saying that there's something traversing through a medium, but that thing is not the medium itself. When you just gave an example of the tsunami creating waves in the water, and you're saying that the tsunami is something ab extra to the water, when really you can only define a tsunami by the water, because the water is the wave.
The wave is comes from the impact that you will create it, right? So the source of the wave is not the water. The source of the wave is the earthquake, which is a physical thing. It will hit the water and it will cause the wave to go around,
Now
So
you're wanting to talk about the source of where that wave was initiated. So are you talking about the wave, or are you talking about the source? So when you talk about light, are you talking about where it's originated, or are you talking about as it's propagating?
a physical impact on Earth, it will shake the ground under the oceans, and those movements will move the molecules of the water. Is that
So
true? Is that correct?
so
Yeah.
what is the tsunami if it's not the compressions and rarefactions of the
If it
water
wouldn't be
itself?
water, if it wouldn't be a water, if it would be something harder, you would have a probably you would have a different magnitude of tsunami. And if it would be air, it
The
would be like
concept
nothing.
remains. The concept
Yeah.
remains. So when we're talking about light, you're saying that it is a wave. Nothing can be a wave in and of itself. Something needs to be waving. So that's why I'm saying you're trying to remove the thing that's waving and call the wave something else and claim as though it's something ab extra to it, when it is, in fact, that in which is waving. So is there a
Exactly.
wave in a medium other than ether? And if that wave is in a medium other than ether, then you could say, sure, it's something other than ether that is compressing and rarefacting, causing this wave effect. But you're saying that the
Yeah,
ether
yeah, I
is the
understand.
compression, there's the compression and a rarefaction of the ether, and that is light. So do you agree that in that conception, that light is ether and ether is light?
Yeah, yeah, yeah. I got
Okay.
your point. It's incoherent, basically what you're saying. Yeah, never kind of pay attention to that. What you're saying. Well, yeah, I agree with what you're saying, and this is because I was indoctrinated in school. Like, I do understand what you're saying that they're interrelated. They're like you need
Yeah.
both to get at the same time. Yeah, I do understand that. Yeah, that was a good point, basically, what you made up. But unfortunately, this is how we've been taught in school. Like waves are different, mediums are a different type of things. Right? Yeah, they're distinct. Yeah, but I do understand your point here. Yeah, that might be revolutionary, but it's not. We're not in the right time, my brother. It's the end of the time. Maybe later. All good.
So then the equator, it can't be a circle as well as a straight line.
Well, it cannot be a straight line because that's based on topography, cartography. If you choose a bunch of cities on the equator, and if you start repeating the experiment, you're gonna come up with that it's not a straight line. That's for sure. But if it's a perfect circle, even that's not for sure. This is what I'm trying to tell you. It's not a straight line, and it doesn't need to be a perfect circle.
So if it's a circle, it has a circumference.
If it's a circle, yeah.
How do you get that circumference?
Okay, so look at my profile picture right now, bro. Look at the projection on the wall, the stereographic projection, right? And I want you to just notice that some of the lines they do not represent a circle, though they're curvy lines, right? It's like
those are cool projections and models. I'm talking about like in
I'm
reality.
trying to tell you that you can have a curved line without being a perfect, arch. It's not a perfect arch, but it's kind of have that curved thing in it within
Which
itself.
one of those three
I guess
things do you think is reality?
I think the one in the wall is the reality
The one
because
on
I'm
the
a two pole
wall
flat
is
earther.
reality?
I'm a two pole flat earther, so I believe in that one. But probably you believe in the bottom. The Globers believe in the sphere. But yeah,
So
I
you
think
think
it's
that on the wall is reality?
yeah, because it has two poles and it's flat. It can explain a lot of things in our reality, basically. So those things that we couldn't explain before. Trust me,
So
it is what it is.
does that have two suns on that one?
It's just the one sun. Just the one sun that it goes around the two poles, basically. Like
Is it like a
oscillates.
figure eight? How does it work? Because it goes clockwise at one pole and counterclockwise at another quote unquote pole. How does it work? And like in your mind, how do you imagine it?
Yeah. So this is the same reason that the sky in the north goes clockwise and counterclockwise in south. This is the movement that we see in our reality. It's something that we cannot ignore it. So yeah, we have two opposite motion, one clockwise, the other one counterclockwise, and we can observe that. Now about the sun would have where are we standing on? Basically, sun comes from east, goes to west. But if you go back to the final experiment, and if you look at the movement of the sun, you can see sometime like within this winter solstice or the southern summer solstice, when they were there, McToon and the rest of the people, they had the sun like going from west to east, right? Because they were seeing it going circular, right? It was just going like a circular above them.
Is
So
west
it
and
means
east points as well? How you're saying north and south are locations, right? Are east and west also locations when you're saying it's coming
yeah,
from?
yeah, it's a location. It's a location. Yeah, exactly. East comes from Eastern world like Asia, Japan, and West will be United States. And in between is the Pacific Ocean, where none of us have ever been there, and we got a lot of and that's the problem where it comes from. So the problem that we flat earthers have is that we don't have good knowledge and information about the Pacific Ocean. That's why we fail to come with a good circumference of the
Well, don't
AE
say we,
model.
just say you. Say what you think.
Well,
Because
because you
Noah
cannot
lives in
explain.
Hawaii and he is in this chat. Well, not
Yeah,
right now, but
basically, no. Basically, if you just do the math with the AE model, you get about 6,000 kilometers for your circumference, right? This is the thing that we would that's 69 miles per degree, right? That we spoke right now. That would have give us the radius, which would be 10,000 kilometers, right? Now, if you just do the math, you're gonna end up with a 60,000 kilometers in circumference, and that is the issue that flat earthers have. Because in the reality, we know the speed of the sun, and we know the timing is 24 hours, and you can easily come up with the 4,000 kilometers.
Well, you
That's if
said
you're
in your
well,
worldview, it's the wall. So you're saying that the equator is a straight line.
set that equator on the AE map based on the calculations that you can do on your
Why
reality.
are you
It would
talking about the AE map and saying we flat earthers? You said it's the thing on the wall, and the thing on the wall. Am I wrong when I say that? The equator
no,
is a
yeah,
straight line.
it has the equator as a straight line. So on that
Equator is
day,
a straight line.
the sun has to like go into a portal, and then
no. That's a problem. Okay, the straight line in the middle, you can just take that off. That is for just make you to just easily visualize what is there. You cannot find it. Okay, let me just ask you this question. Can you just show me a one star trail that goes straight? No. Even in the ones on the equator, if you follow them, eventually they will deflect to right or left. There's
I
not a
feel like you're leading me
single
down a haunted hayride conundrum. It's like a rabbit trail. The equator is a straight line, and it's a circle, and it's also a circle and a straight line. So,
based on what? Based on what?
what do
Based
you
on what?
believe the equator is? Do you think the equator is perpendicular to north and south?
Exactly.
You do?
So,
So it's a straight
so
line.
equator. Look, so when you're talking about equator, you're talking about zero. Did you know that you're talking about zero? So when you're talking about, you have to understand zero doesn't exist in
Zero.
nature. Yeah. So
Why are we
if you
talking
go
about
straight,
zero?
because this is your 0 point, it's your reference point. Yeah, that's your reference point. So, and I told you, there is no
That
straight
is
0 point
correct.
over there. You get close to this zero, and this is how things works in nature. You get close to it, and you go away from it. So the sun would get close during the equinox. The sun will get close to this imaginary straight line, so it doesn't go on a straight line. It's very, very close to it, and then eventually it will circulate around these two poles. And the day after the equinox, again, the sun would have go on a very straighty line, kind of look like an equator, but eventually it will deflect to the left this time because it wants to go to south. There is no physical straight line that you can have this physical straight line on the ground, but you cannot show me any physical straight line in the sky. You have to imagine it. And why I'm
So that
telling you that is because, yeah, because the star trails are good patterns. Star trails do not expose any straightness, not at
but
all. Even the ones in the equator.
the
Yeah,
star trails
go on.
show what you're saying as there's two locations of north and south, right? And the star trails show that, but you said east and west are also locations. But I don't.
Yeah.
So that means I could circle around east. Like I'm confused here on
So
what you're
you want to
saying.
circle? You want to circle around? Okay, how you want to circle around? Are you allowed to do that? Are you allowed to go to the Pacific Ocean? Have you ever flown over the Pacific Ocean?
Yeah, you can go
No,
to
none of us.
Hawaii. Yes.
You can only go to Hawaii, but not further than that.
What about the French Polynesian islands, like Tiapu?
Bro, they're all in the west coast of the United States, and they're pretty close. And I'm saying, okay, if you
Oh,
go
that
there,
one's not
and
close to the United States.
where is it? Is it the middle of the
The, Fr-
Pacific Ocean?
the French Polynesian islands, kind of.
Yeah. So the equator. So yeah, even if you can go that, even if you can go over
Wait,
there and
do we need to pull up
track
a
the
map of all the ships traveling across the world right now to see if there's any in there? Is that what
There's
you're saying?
yeah.
Papiti Tahiti. There's Tuamotu. There's the Austral Islands, the Gambier Islands, the Marquesas Islands,
Well,
Teohe.
we better not
A
look
lot
at
of
those.
French Polynesian islands over there.
Okay, let me give you another way to understand this. Okay, even if you would have those islands, right? Even if you go there, even if you track the sun, right, over there, you're gonna see the sun is going around the North Pole, and during the winter it's going to South Pole. Now, if you're looking for a straight line for equator, I'm telling you that straight line for equator does not exist in your reality. I'm telling you, it doesn't exist. That's an
It is
imaginary line.
reality. You're the one who's claiming that that wall is what reality. That's what it
What
looks
wall?
like in reality. No one else is
What
claiming
wall?
that. So what are you saying? Don't say what other people are saying, or we, or they. What are
What
you
wall? What
saying?
what wall? I didn't talk about any wall. I was talking about the equator. What wall are you talking about?
You said
What?
that if I look at your profile picture, the one that most closely
Oh, okay.
represents reality is the one on the wall.
So which one you think represent the reality? The bottom one?
Well, if
Why
pi
does it
equals
matter what
2,
I
it'd
think?
be the
I'm
No,
one
no,
in
asking
no.
the
what you
middle.
think.
Yes or no? If it's yes, I will mute my mic and I'm done with this conversation. If it's no, then we can carry the conversation. If you still believe in it, if you're a flat earther who still believes in the AE map, I don't have any words with you anymore because there are 1,000 things that you haven't understand if you think that the AE map is
Is it
correct.
your
I'm
claim
sorry.
Oh,
that it would have to be one of the three? It has to be? And
No, no,
if so,
yeah, I
why
believe in
would
your
you
mind.
make that claim if that is your
Well, because what do you mean? Because I'm saying basically people believe in the flat AE map or the globe model, or like there's a dude here. I
Like
think he
you're
believes
saying
in
Please,
from a
please,
pole.
8 years of schooling. Please, just try to answer one question.
I
Is
think he's
it
saying
your
like he took a.
claim that it has to be one of the three? And if that is your claim, why does it have to be one of the three? Please.
No, bro, my bad. Okay, my fucking bad. It can be anything. You go on. What do you believe?
That's
What
wrong.
are you
He
trying to
asked
say,
you the
Mr.
question. Why are you avoiding the simple question that he asked you,
I
though?
don't know. It's very
Bro,
strange. 8 years of
okay, bro,
schooling,
there are
man. I don't
four
know how you
options.
go
There's
through
four
8 years of
options.
schooling and you're not good at answering questions. I think you answer a lot of questions in school, 8 years of schooling.
No, you're not asking a good question. You're saying that okay, if it's not these three, then what? It cannot be something else. Yes, it could be something else. If you have something else in your pocket,
No.
just show it to us.
It could be
You don't have
reality.
anything else, so choose.
Eight
Okay,
years
choose
of
one of
school and I
one.
give you an F. You didn't answer. You get an F. 8 years
Yeah,
of
well,
schooling gets an F.
and your profile picture is incorrect as well. That would not be the picture on the wall is a conception by Charles Proteus Steinmetz.
It's still the globe map and all three.
It's by who, bro? The
Charles Proteus
chart on
Steinmetz. The image on the wall is I forget what he calls it. Something of a circuit, and it's from Charles Proteus Steinmetz.
It's all
bro.
projection.
This is
All
another
those.
bro. This is a 2-point projection of the globe model, bro. What are you trying to make it hard? It's not. It's a mathematical projection.
So it's
It's not
wrong.
from anyone.
So it's wrong. Just
What
as
do you
the
mean it's
AE.
wrong? What do you mean it's wrong? I
It's
don't get
wrong. Just the same
this
as
one.
the AE map.
Why? Okay. Oh, I thought that you were saying wrong. It's wrong that you can. Okay, so math. Do you agree that mathematically we can just do that on the globe model? We can project it with the 2 points.
Yeah,
Are you able to understand
mathematically, I
that?
can make Superman jump over the Empire State Building. Doesn't make it true, bro.
No, you cannot do it. You cannot do that. So basically, if you
Mathematically,
look at the
yes, I
projection,
can.
either
I could
no,
give you
we're
the
talking about
I could
projection.
give
No,
you
no,
how
no.
much.
Don't do the straw man. We're
I
talking
could
about
Don't
give you
talk
projection.
how
over
much
him.
force Superman needs to have to jump over the Empire State Building. So yes, mathematically, I could do it.
Projections. We're talking about projections. So either you
Yeah,
can project
you
around
said
one
mathematically
point,
though.
bro. You can project your globe model around 1,000 points. It doesn't matter. Okay,
Yeah, it
so
doesn't
it's
make
not
it
from
correct.
anyone. This is a mathematical procedure. It's called transformation. So
Yeah, it
okay,
doesn't make it
so
right though.
okay, I'm glad that you understand this. So it's not by anyone. This is just a projection. It's like you're
Good.
saying that 2 times 2 is by fly. 2 times is 2. It's just math projection, right? It's a math process. So you can project your globe model around any point. The points that
Okay.
we have chosen is going to be the north and south, and we have a good reason for that. For north, probably you guys have good idea. You guys know why we do it on north because your AE model is based on north. Now we have added another point
Our
here
A
in
model.
order to make.
What the hell?
Yeah, on any marble, you're just projecting around the
Wait,
North
We
Pole.
don't have a
in
we don't
reality
have an
though,
A
right?
model.
We measure 69 miles per 1 degree, right?
Yeah.
Let's just
Have you actually walked those 69 miles?
no.
Yeah.
I'm asking. Shouldn't we do that as a community, right?
Yeah, we should, right? I mean, they say that, but I mean, we have to ever actually pace it.
If
Oh my
everyone
God, you
did
guys.
that, we could figure it out. If everyone, took an
Oh my God.
angle to Polaris, well, everyone in the northern hemisphere, and then
So you
traveled
guys don't believe in.
69
So you
miles and
guys
did
don't
it
believe in
again.
stellarium. So you don't believe in stellarium. Think that stellarium is showing the bullshit in the sky because you don't need to do it
What does that
physically.
have to
You
do
can
with
use.
what I'm talking about?
We're talking about in reality. We're
Yeah, we're
trying to
talking
do this
about
in
No,
reality.
you're talking about models and stellarium and stuff.
no, it's not a model. Stellarium is not the GP of the things that stellarium is giving you. It's not a. It's accurate enough. I thought. God,
Accurate
this is
enough.
like a headache. This is like a pain in my ass. The
Accurate enough.
stellarium.
What do you mean accurate enough?
Yes,
So it's
it means
not actually accurate then.
what?
It's
Why? It
enough.
is the GP. The position of the things that you see in that software. It's pretty accurate. I'm
Pretty
sorry, it's
accurate. So
accurate.
not actually accurate as reality. Okay.
Hold on. The reason
Yeah.
that a lot of people figured out they were lying to us about what Earth is, like what the model they gave us, was because they went into reality and tested it with a tool that exists in reality, a water level, which sets up a horizontal plane locally, right? And horizontals are parallel to one another. And any line perpendicular to that would be vertical, right? So this is how we know there's something off about what they sold us, right? So why would we go back into a model to try to when we just stick with the reality? Because the reality seems to be giving us stuff we can know that we could actually experience.
Okay, just do it by okay. Do this as a community. I'm gonna be patient here because I have this argument with a lot of flat earthers, and all it's like a pain in my ass. And they will waste their time to just double check everything. They kind of think that everything has been lied. Okay, you guys can go do it by yourself. But once you guys realize that it's gonna be 1 degree per 69 miles, then come here and then you guys gonna listen to me
How do
from
you
that
know that
point.
exactly?
Okay, would that be a
Okay.
radius value then at that point?
Yeah, how
No,
do
no,
you know that
just
exactly? It's
go
actually
find the 60
69.
knots per degree.
How do you know
Just
that
do it by
exactly?
yourself. I use Stellarium. I have used it by my own self. I know how to use a Stellarium because, look, Stellarium, I know it's based on the
Yeah,
globe
but how do
model. You
you
guys think,
validate
oh,
those
this is the globe.
69 miles, my friend? I'm not asking you how that you what model you use. I'm asking you how do you validate that 1 degree per 69 miles? Meaning, did
Bro,
you
what are you talking
actually
about? I
went
didn't
and
go
measure
forward.
69 miles and then check if it went down 1 degree?
Oh my God, this is crazy.
And
Uh,
take it that at
if,
60 you have to wait till the next day because if the when as time changes, I mean, unless you're going straight off of the
no, you don't need to
Polaris.
wait to stay. No. You have to get in your fucking car. You have to move. You have to increase your latitude. And once you're increasing your latitude, you're going to see the Polaris start descending. And if you just if you just plot the relationship, I told you 1,000 times, guys, don't do it do it to yourself. It's going to be a linear relationship. Don't
I'm
repeat.
asking you, when did you do that yourself?
Bro,
Did you actually
I'm
went?
just giving
Did
you
you
my
go those
words.
69
I'm a flat
miles
earther.
and check that
It's
out? Oh, jeez,
Oh
dude.
my God! This is the reason why Globers are making ridiculous, trying to ridiculous because of these things that you guys are saying.
So
Yeah,
what
but you're
exactly
trying
do
to
you
say you
think is
confirmed
being
this,
asked of
you
you? Oh,
validated, and
sorry,
you
Allah.
haven't shown us validation, man.
I'm giving you my
Kaiser,
words. It's
what do
going to
you
be
think is
69
being
miles per
asked of
degree.
you?
That's for sure. That's for sure. Okay,
You
that's for
validated
sure.
this.
Yes,
How did you
you can
validate
do it by
this?
yourself. You can do it. You have to move on toward the Polaris and see how does it move.
Did you
You have to
do
do it by
this?
yourself. What?
Did you do this?
Yes, I've done it many times.
Could
Even
you
for South,
describe
when
Stop
the
sounding like you're
process
lying.
that you've
Oh,
done,
even
please?
for South, you have to do the same thing. Now listen to this. Listen to this sport. This is going to be very interesting for you guys. You
Yeah,
can do the
I already
same
doubt
thing
that.
for South. You can do the same thing for South, but the problem with the South is that we don't have a star in the middle. So what you have to do, you have to imagine. You have to put an
So,
imaginary point in the southern sky, and if you do repeat the same experiment, you're going to get 60 miles per
oh,
degree again for South.
experiment. Dude's all over the place.
It's a symmetrical reality. So
Yeah, but
South
I
and
mean,
North.
so if
Yeah.
you were actually validating this, that means you documented it. So okay, we got documentation of you actually doing this when you pace 69 miles and actually measure the degree of angle change.
Mm-hmm. Yeah,
Where you got this? Where
this
you
is
got
this is
this?
bro.
You post it.
This is a like a 12 year. To be honest, this is a very stupid question. Like, don't ask this
You
in front of the
post
Globers.
this.
Kaiser, could I just ask you, what do you
Oh my
think
God.
you're being asked? You keep saying there's a stupid question being asked to you. What do you think you're being asked?
When you get close to the building, do you agree the building starts ascending in your view? Can you understand this is a fucking relationship? Distance
Hang on.
between you and the building
Alright,
and the height of the building is a fucking linear relationship in your reality. You need to understand. Stupid flat earthers
Bro,
don't want to
chill
respect
out.
anyone here. But
Chill
you guys
out.
are just no. I don't want to
Chill
chill
out.
because you guys
You're
are
fucking
hurting me.
crashing out, bro. You're
We're
crashing
in the
out.
same
Relax.
side. You guys in the same
We're not
side.
here to listen
I'm
to you
telling you,
freaking yell. Chill
It's
out.
spiraling.
Yeah.
it's a
Otherwise, we're gonna
building.
mute you,
It's a
bro.
building. It's a
We're gonna mute
building.
you.
You know that. Listen to me. If you start moving toward any object, the object starts to rises. And if you move away, it starts to descend. This is a linear relationship. That's it.
Yeah,
I'm
we
done with this
know that.
conversation. That's it.
It's not
That's it.
It's not.
it's arbitrarily linear.
It
It
does.
becomes
The real,
hyperbolic at certain points. That's the problem.
yeah, the question is that whole building thing that you described would be Euclidean, but it seems for some reason this angle measurement is non-Euclidean.
Yeah.
So you're saying that you guys repeat that and it wasn't the case, like it wasn't 1 degree per 60 degrees, 69 miles? Is that what you guys are
said
saying?
that you did that, and we were trying to ask how you did
I'm
that, if you
telling you,
could
I did it
describe
by
the
myself.
methodology.
And if you guys are lazy to do it by yourself, you don't have the money and the time, go in
Okay, but
software and
if
do
if
It's
you
a
do that
hyperbolic
measurement,
relationship. It's a
If you do that
hyperbolic.
if you do that measurement, are you deriving a radius of a circle, or what are you deriving?
Nothing, just the distance to the Polaris. Don't try to make something out of it. I'm telling you, this is not the right thing. We don't know anything. I know, I might know, but I'm
Not,
gonna talk
not
about it
he.
later.
What Torah asks, right, is valid because if you were to graph it out, actually going on in reality, you end up with a parabola. You end up with a curve, right? It's not linear; it's a
It's
curve. And hold
it's gonna
on,
be
and when we talk about declination and right of ascension, when we're looking at Polaris, do you know that in real life, right? It's not linear. It's not a
In
linear
reality, yeah.
graph. In
In
reality, it's not
reality.
a linear graph. It's from 0 to 15 degrees, it experiences more refraction, right? Then from 15 to 75, and then from 75 to 90 degrees, it experiences the least refraction. If you were to graph that out, and Shane's the one who pointed this out originally, where I learned it from. It's a
I don't
logarithmic
know
relationship, not
why you're
linear,
bringing
not linear.
distraction.
The
No,
Why you're
linear graph.
bringing
Hold
distraction?
on,
Why
hold
you bringing?
on, because you keep asserting that's linear. No, the linear graph that we all know, 1 degree per 69 miles, is arbitrary. That is a convention that they created.
But if it is
Oh
linear
my
in the
God,
60 degrees between 15 to 75, that still is larger than 3959.
in
guys, you
reality,
know why you guys are
yeah,
so
it would
stupid?
be.
You know, did you know that if it's not linear, your fucking flat Earth model is debunked? You guys are
What
It's
model?
flattened
stupid.
at the poles, brother.
Oh my gosh,
Flattened
I
at the
cannot
poles.
believe this. It has to be linear, otherwise it can't be on a Euclidean
We're
flat Earth
talking about
model.
reality. We're not talking about a model. We're
Okay,
trying to
Oh,
talk about
cool, cool. I
reality.
like that. I like that. I like that. Okay,
hey,
so you guys are
Karsa,
saying that basically. Okay, so you're saying that
Karsa,
from
chill.
some
Hey, take
points.
a deep breath for a second, bro. Do you think that measuring to visual space is a Euclidean function, meaning that your visual space, measuring to stars, objects, anything like that in the distance, is purely Euclidean?
What like the distance of it or the speed of it? What are you looking for here?
Yeah, he
Like if you're
does
looking for,
because he said the sun is
I'm looking. Yeah,
3,000 to
it's gonna be
4,000 miles.
the
Right.
angles. The
Angular
angles.
measurements to things in your visual space. Do you
It's
think
Euclidean.
that
Yeah,
that
yeah,
is
it's Euclidean.
Euclidean?
Yeah, this is how navigation works for 3,000 years. I'm sorry.
Okay, so then you're incorrect in your assumption that our visual space is Euclidean because that's where the navigation that's worked for hundreds of years is being projected onto a sphere because the ground is not a sphere, even though we see in a non Euclidean fashion, meaning that we take angle measurements to objects in the far distance for our navigation, meaning that all angle measurements are always going to be, right, in the form of a sphere if it's three-dimensional. You have a 360-degree axis around you left to right, and then you have 360 degrees over and above you. That all fills in to be a sphere. So if you're measuring to that surface, it's non-Euclidean. It's a non-Euclidean surface. And it actually becomes hyperbolic. It's not a perfect sphere.
Well, this is getting very messy. Like I don't know. You just brought up something else here. You're saying that okay, if it's not even Euclidean, so what is it then? If you
Well,
have
you're
an answer
you're
for,
saying that our measurements have to be Euclidean in order for the surface to be flat, meaning it's like a planar measurement. And that's the problem is it's the assumption that people make using straight trig and using just Euclidean math on our visual
Facts,
space is what gives us the assumption that we live on a ball.
Well,
facts. Because
but
of
the water,
because of curved visual space, they make the assumption that we're on a ball.
but the
That's it. That's what it is.
but the
Go ahead.
water level is a tool in reality that sets up a horizontal plane, right?
Locally. Yeah, it does
Locally,
that locally. Yeah.
which
Right.
which is Euclidean, right?
Yeah, we can
okay, so you're saying that
establish that
basically on
horizontally.
Stellarium. I just opened my Stellarium right now again, and I'm just seeing this linear relationship between the position of the Polaris and the city that I'm living right now.
Yeah, that's a
So,
globe.
bro, I'm just checking with the reality. Okay, I'm just checking, double
No, you're
checking it
not.
right
You're
now.
checking in a model called a globe.
Now, I can use my phone. Then I can just point
If
the
you
star
subscribe
with
to
my
the
phone and just do it.
concave model, you're obsessed with models. You have a model affliction.
Well, let me
No,
just
no,
give
no. I
you
don't want
this.
to get into the
Let me just
concave.
give you this idea, Karsa. So, if you're talking about, you even said earlier, talking about like a building, right? You move further away from it, it gets lower down in your visual space, meaning that the top of the building is going to appear as though it's closer to the floor the further you get away from it, and the closer you get to it, the closer it's going to be above your head, right? So you can see that on a flat plane. Would you agree? Now, if you map that
Yes.
in the way that
Yes.
you're trying to use Polaris and say, oh, it goes down towards the horizon and then it cups up and there's this linear relationship here. If you make the assumption that you're on a sphere, you can do that, but you can make the
No, no,
assumption
no.
that you're on a flat plane and that object is getting just further and closer to you.
So here's the thing. You guys agree on the equator, it will be at 0 degree, and and exactly on the North Pole will be 90 degrees. Do you guys
I,
agree with this? These are yeah. So what about the
I
latitude 45
disagree with
degrees?
Yeah, not yeah, because
You disagree with
not all the times.
I
what?
disagree with that because it doesn't happen from from like 0 to 15 degrees. You don't have a perfect linear relationship. And same from like 75 degrees to 90 degrees, you don't have a perfect linear relationship. So no, I disagree.
Yeah, because of the refraction, because of some other things, but
What, hold
basically
on,
yeah,
What is the refraction from 75 degrees to 90? What's
75 the refraction.
the
So you're saying
refraction
that from 79?
explanation
Okay,
for the
hold
difference?
on. No, and not from 79 to not from 75 to 90, from the lower angles that you said from 0 to 15 degree or 0 to 20 degrees, because since it's too close to the
So
horizon,
what is your
it has to pass
explanation
through.
for the deviation from perfect linear relationship from 75 degrees to 90 degrees?
Well, I'm not sure about it yet. I have to double check that whether it's not a linear relation from 79 to 90. So you're saying that from 0 to 75 it's going to be linear, then from 75 to 90 it's going to be non-linear. Well, this is a new thing.
Nope.
I heard it. And I'm going to study
That's
about
not what
it
I said.
and we're going to talk about it later, okay? I'm not sure about it, but you're claiming that it's going to be a non-linear relationship from 75 to 90 degrees. Is that right?
Yes, it is a nonlinear relationship from 0 to 90
Okay, cool,
degrees.
cool.
There is
Now
not a
listen to me. Listen to me.
consistent linear
Yeah,
relationship.
yeah. I've been in Swal. I told you I've been in Svalbard. It's in Norway. I've been there like I think it was 4 years ago. My sister lives in Norway. I went there, and actually, if you look at the latitude of that city is 80 degree, positive 80 degrees. And if you go there, you can see that the Polaris is almost 10 degrees away from you to get exactly be right on top of you. Like it's like 80 degrees. You can see it. So you got 80 here. Now you get nine. You get when you go on this equator, you get 0. You got 90. When you go on the North Pole, you're exactly at 0, and that you're at the 90, and the angle is 0. So if you, as I told you, I have chosen 3 points. You can, and this is what we do in mathematics. When you want to find the function of any line or any process, you need a couple points, and if you increase your points, you're gonna get a better approximation. But I did it but a couple points, and if you do it by 0, 45 degrees, 90 degrees, and let's say 60 degrees, if you do that, my brother, you're gonna see it's a linear straight line. Now you gave me a good new claim. You're saying that it's not linear, and I'm saying, okay, bro, let me just double check that out. Let me just see what you guys are saying. Cool. Cool.
Are you guys talking about like the angles to Polaris?
Yeah.
Yeah.
Yeah, well, I thought we've already discussed this, and I've already shown that once it gets close to the horizon, things do getting weird, and then that's when you guys come in and have your excuse for refraction.
Okay,
It's
So
not
but
tell me
even like
when
the whole
last time
thing. The whole thing is based off of the latitude. The latitude lines. They're all equidistant from Polaris. But the thing is, dude, that convention of 1 degree per 69 miles is just that. It's a convention. It's arbitrary.
well,
Because in
is it a
reality,
circle though?
Well, that's how
it's
you
not a
got.
linear.
That's how
You
they
have okay.
got the
So
latitude line.
hold on. So in a graph, we have linear, exponential, and logarithmic. Right. What we see to Polaris is not linear. It's not exponential. It's logarithmic. It's what happens when you actually graph it up from 0 to 90. It's a logarithmic function.
And that's how they got the
okay,
latitude line. So they can't really just say, "Oh, look, it matches. That means our model is correct." That's how they made it.
Well, this is the
That's
interesting
what we.
part. Is if those are circles, then like, because he was just saying like if he took that from 3 different points, 0, 45, 90, or whatever, But what if you just kept going 45 and you follow 45, right?
Yeah,
And you
that
keep
that
on
was the
getting
exactly.
and you
Yeah.
keep
So
getting 45 degrees, right? Do you end up back in your same spot that you were when you took the first angle measurement if you just travel? So is that a circle or a straight line?
okay, so good. That was a good point. So you agree that on the equator it will be 0. That's for sure. Now I want you to do this. All of you guys, I want you to check this right now. What is the altitude angle of Polaris at latitude 45 degrees? What is it?
Yeah,
Right
45.
now,
We
It
get
just
that.
varies.
Yeah.
It varies.
that's it, bro.
It
That's
varies.
it.
Polaris is
That's it.
unseen, but
Oh, okay, listen. So we got 3
you can
points.
see
We
Polaris
know for
sometimes at
sure,
the equator.
bro. Look. I do understand your arguments. Please listen. We have
Okay.
chosen 3 points. One on the equator, one on the latitude 45, and one on the 90 degrees. And we know that it will pose a linear relationship, right? Now, if you guys are saying in between, it will behave differently. And I said, okay, that might be true. But if you look at these 3 crucial points, 0, midpoint, and the end point, my brothers, it's a straight line.
No, I'm talking about 45. You missed my point. Well, I'm talking about at 45 degrees, you take angle measurement, then you go west, right? And you go west, you take another. You
Mhm,
stay on the
mhm,
45-degree line. So you keep Polaris at
mhm,
45 degrees of your angle of
mhm.
declination, right? So now,
Yeah.
when you're doing that, will you end up back in your first position? Yes or no? Eventually.
Oh, yeah.
Yeah.
Yeah. Yeah.
So that's not a straight line, right? That's a circle.
Exactly. I told you
Okay,
it's not a
so if
perfect.
it's
Yeah.
69 miles per 1 degree, that's a radius value that you can work out 69 times 90 and
It's
get.
not a perfect circle. It's not a perfect circle. Told
Then
you.
it wouldn't be, then it's not 69 miles per 1 degree.
No, it is.
You
It
just
can be 600,
refuted the
but it,
69 miles per
Oh,
Oh,
degree.
my
also,
gosh,
imagine
it
just
it.
says
real quick, if it's
Imagine
69.
it.
not
Hold.
if it's
Imagine
not a
elliptic.
perfect circle, you don't end up back where you
Imagine
started, by
elliptical.
the way. If it's not a
Well, if
Well,
it's
perfect
hey,
an
circle.
ellipse, he's
why is
saying it's an
Polaris
ellipse or
fluctuate
something.
its altitude slightly when you're at the same location on different throughout? Like sometimes Polaris, you can see it like higher, like even if it's only a tiny bit,
Do you have
based
evidence
on
for that
atmospheric
claim?
conditions.
Have you done that? Have you
I've
measured,
seen
word
people,
salad? Have you measured an angle to Polaris?
not
In
personally,
reality? No, okay. So we're trying to
no,
stick within
but
reality here, things that we've done, right?
yeah, but the
Yeah,
globe has a
No,
claim,
like
and
thought
the thing is, people
experiments
have not.
or imaginations or
I'd have to
anything,
see
just
the
in
source where
reality.
someone just went and that matched perfectly. And if
You
you're
know
going to
what?
play
This
with
is
that,
something you can do personally in your own reality locally. You can go take an angle measurement right now from where you are to Polaris, and then you can
no,
travel 69 miles and then take another angle measurement and then
no,
travel another
but then why
69 miles.
it starts getting weird at towards the horizon, and then that's when the globe claims refraction.
It doesn't
Okay,
matter, even if it is weird from 0 to 15, okay? You and 75 to 90. Let's
and that's
just
where it
grant that
start
it's
getting weird
weird.
on a flat Earth.
Okay, let's grant that it gets weird there, right? You still have 60 degrees of this linear relationship of 69 miles per degree, which gives you larger than a 3,959 mile radius. So the circumference is going to be larger than what the equator is claiming.
Thanks. Yeah.
So why would it not do that on a flat Earth? Wouldn't you expect, with perspective, that as things start getting way further away, they'll start to change their linear relationship?
You would need a negative, it would have to change in a negative function that when you went 1 degree,
And what are you assuming the
you
distance
went
to be?
negative 10 miles. That's
Are you
impossible.
assuming the distance? Are you assuming the distance
What
to the star?
distance?
Are you assuming the
And I
distance up sooner, or they'll have they will drop different types of ways based on your altitude relative to them? So if you're assuming the altitude to the star, you're going to be making a lot of other assumptions too.
I'm not assuming any altitude to the star. There was no assumption of altitude. We said here on Earth, in reality, locally, if we measure, if the I think the consequence has to be that there is the 69 miles per 1 degree doesn't exist anywhere, is what you would have to say. Because otherwise, if you're going to take the equator as a circle, the circumference is 39,900 miles or something like that. You get that, right, word salad?
I don't claim a map of the Earth. I claim a general map of the AE, but that's all. And I don't claim sizes. I don't claim
Okay.
distances.
Well, if it is the general map of the AE, then pi equals 2, right? Because 69 miles per 1 degree times 90 gives you 6210. Then you times that by 2 times pi, you get 39,000. But the equator is reported to be, 24,901, which would be pi equaling 2. And does pi equal 2 in reality?
No.
Wait, so are you talking about when you travel longitude or latitude?
I'm just talking about like traveling latitude around the equator. The
Okay.
equator latitude, right? They claim is a great circle route of 24,901 miles. Do you
Yeah.
agree or disagree with that distance?
I'd have to try verify that more. I could agree with that, but not for sure.
Yeah, well, if it's 69 miles per 1 degree, invoked a curve of some sort. Because in reality, it's 3.14159.
I think you lost me. I'm sorry. I'm not that great with. I'd have to look at the equations, but
Do you have access to Google Word Salad? Is that who we're talking to?
yeah,
All right,
yeah.
so
But
if you do
I don't use it, but I
69
can, I
times
guess.
90, what do you get?
69 times 90.
Whatever number that is would be if you assume, if you assume 69 miles per degree, whatever number you get, that's your distance in miles to the equator from the North Pole.
Yeah, you have to make the assumption of a pole, yeah.
Yeah.
Okay, so
That puts, you could put north in the center, and you could put Polaris directly at its zenith. Whatever number you get, that could be your radius, and you can make a circle. And if you get the circumference of that circle, that's the circumference of the equator, if you believe that it's 69 miles per degree. Right?
okay.
And north
Yeah,
is a
then
center point.
so you're saying the size of the equator would be wrong if you're using the angles to Polaris plus plus the radius of the Earth at the equator.
Well, if you do the math, what do you get? It's like 39 something when you get the circumference. But if you make pi 2, you get 24,901. But pi doesn't equal 2.
And remember, the equator, the claim is the sun travels at 1,000 miles an hour and a day is 24 hours.
It's not a
Yeah.
claim that this is
Well,
another.
yeah.
This is
Sorry,
it's not a claim.
I'm not talking much. I'm eating right now, but yeah.
Well, okay, let me just tell this to Tora. Tora, this is not a claim. Come on, guys. You guys are just saying that everything is a claim. We know the velocity of the sun. We know in physics, we know that distance is equal to velocity times time, right? Velocity multiplied by time. D
Well, say what
equals
you know.
vt.
Don't say we know. Say what you know.
So I know that the distance is equal, bro. You don't sound correct or right. Anyway, so we know
But
that the
you've been
distance is.
corrected on that like 17 times today, bro. Like just say
What's
your
the distance
claims.
to the sun?
Okay, never mind.
You
Never mind.
you have a bunch of pseudoscience about the sun.
No, yeah, you can still think that we don't know the velocity of the sun.
Who
Yeah,
is
you can guys know
we?
what
Who is
so,
we when
What's
you're
the
talking
distance of
about
the
we?
sun?
you guys, I don't know. You guys are claiming that we don't know that this is
Yeah.
like
Is
the
we in
velocity
the
of
room with us right now? Who are these people? Are they in the room with us? Can we talk to them? Who are they?
I'm talking
Yeah, we just
you.
want you to speak for yourself, right? We're not interested in hearing what they say. I just want to know what you say.
velocity? What's the velocity of the sun,
But
man?
Do you
this
agree
isn't
that
what
we
he
can?
said.
Do you guys understand that we can find the velocity of the sun?
You got a
How do
distance
we
to it
do?
too.
How we do that? Somebody explain to me how we can
You have
find
the
the
distance
velocity.
to it too.
No, 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 not the distance. Don't straw man me. Just tell me how
Yeah,
we can calculate.
one way we
You
could
need the
do it.
distance. You
Yeah,
need
one
the
way
distance,
we
bro.
go ahead. One way we can do it is we can assume there's 24 hours in a day, right? And we can base
Oh, so
all
you
of our
assume that there's
measurements off.
24 hours in a day. Oh, so you
Yeah.
assume that. So you don't believe that the day is 24 hours. Is that
Well,
right?
why? Well, why is there 24 hours in a day? Who came up with the hour? It's
You guys are
because there's
genius.
60 nautical miles in 1 degree, right?
And velocity is
So
relative. So relative to what?
no, no, I'm sorry. I'm totally sorry for you guys. So as I told, back to the experiment that I told about the sun, distance of the sun. We know that the width of the United States is about 3,000 miles. We
Wait,
know
wait,
that
wait,
area.
wait, wait. Before you move on to another point, you were talking about the velocity of the sun. You asked
I'm
us if
trying to
we could
calculate the
know.
velocity for you,
You
bro.
asked the
I'm
room
trying
if we
to
could know the velocity
I'm
of the sun.
trying. Okay,
Okay,
what is the
don't.
velocity of the sun? How we can count? I asked this, nobody answered me.
Right,
How we
then you
can
started moving
calculate
on
the
to the width of the United States. So, like, how
because I
you want
want
an
to tell
answer,
you
but you
how
also,
we can do it, you stupid fuck.
brother, we
It's
can't do this. We can't have audio chaos. I'm just trying to keep the room on subject. We're gonna go one at a time. You go, then someone else goes, and try to keep it concise. We'll go 1 point at a time.
listen.
And no
When I'm bringing
emotional
up
responses.
when I'm bringing up the distance between two cities, because I'm telling you that when we know the distance between two cities, which is about 3,000 miles, and we know how long the sun moves from one point to another point, which is about 3 hours, and if you divide 3,000 by three, you get 1,000 miles per hour. You stupid fucks. You
I thought
stupid
that's what
Okay,
fucks.
but
it's.
you're assuming the
Hold on one
distance.
second. Hold on one
Sorry.
No,
second.
no,
I
no,
just want to make this point. I
no.
thought that was the claim at the equator. Now you just took us to a place above the Tropic of Cancer,
Yeah, he
and you're saying it's the same velocity.
keeps moving the goalpost. But hey, you're on mute, Kasra, however you pronounce your name. Just to let you know, in the server, we don't just blatantly call people names. You can't just call people idiots and start cussing. That's not how we operate. So like, don't talk over people. Give people space to finish their sentences. If you are getting frustrated with the information, then try to just counter it. Don't start calling people names.
But why are we denying things that we can observe? Like the speed. I mean, I understand flat earthers say the sun moves around the top or whatever, but you can most definitely calculate the speed of it.
Well,
Everybody can see it.
let me just finish. Let me just finish my words, and I'm going to leave the room right now. I don't because I haven't benefited anything, and I think I have educated you guys in like more than 3 hours, and I'm going to just say this, and I'm going to leave the room. The
You're
reason I told you
educating
that,
us.
how listen, the reason I asked you that you guys are how we can calculate this like the velocity of the sun, because I wanted to make sure that how much you guys are really know science. Now, some of you guys saying that we
Science.
cannot know. Well, listen. So I asked one of the you guys start answering that. Yeah, when we know the distance and blah blah blah, and if it takes really 24 hours in a
Hey,
day,
if you're
and
just gonna insult people and then rage
no, no,
quit,
no,
just rage quit. Don't do all the insults. All right, that's it.
Yeah,
no,
We
there's
I
no
we
rate.
prefer
need
There's
to
the
no.
know
deductive
science.
method
Okay,
rather than
Yeah, I
the
don't.
inductive method.
listen,
Yeah, I don't like this
listen,
whole like
bro,
I'm gonna
listen.
make a bunch of points, I'm gonna insult everybody, I'm gonna strawman everybody, and then I'm gonna leave. All right. So if you're gonna insult everybody and leave, just leave. And if you want to have a conversation, you can stay. Those are the terms.
Yeah, and don't try to act like you're a flat earther or whatever when it's obvious that you're not. You're just yeah, just be genuine,
Okay,
bro.
so when you know the distance between two cities, let's say one in New York and the one in Santiago, which is about 3,000 miles, right? And you know that for sun takes 3 hours to move from noon to noon, right? It takes 3 hours from sun to move right above the New York to go right above the Santiago. So this is the 3 hours that you have. That is for sure. That is not from NASA. That is not from any.
Is
That
that
is a
on the
real thing.
equinox?
Listen, bro, it doesn't matter. You can do it anywhere. I'm just giving you the method. And I'm going to fucking leave the room, okay?
So
Just
it's
listen
always
and learn something
1,000
from me.
miles an hour.
Listen and learn something from me.
This
I'm
isn't.
trying
You don't want to have a
to get
conversation. You just want to preach at people and ignore what they're saying
no,
to
no,
you.
no, no. I'm
That's what
just
you've been
giving you
doing.
how you can science to find the velocity of the sun. So you know that the
I'm
distance
in
between two
Antarctica
cities
and it's spinning around my
is
head.
3,000 miles.
All right, we can't do it anymore. It's just him yelling. He just wants to yell at everybody and ignore anything that's being asked or said to him. It's all right. We can't do it. It can't be done.
But y'all keep cutting the dude off. And I agree with you, Napalm. He's definitely not a flat earther. He's a troll. I've been saying that.
Well,
But
Carl,
you
do
can definitely.
you agree with that statement that it travels at 1,000 miles per hour all the time? Like, so if we're in New York to San Diego, the velocity is 1,000 mile an hour because that's above the Tropic of Cancer. I thought the claim was at the equator.
At the equator. That's what I was. What the fuck is this guy
If the sun
saying,
is
dude?
traveling 1,000 miles per hour at the equator, why would it? So you believe the sun changes speeds? It speeds up
All
and
right,
slows down?
he
Yeah,
was
that
just
would
giving
be.
you guys he was just giving you guys the method and the formula, not
Uh,
really the
it's
real
not.
numbers.
It's not right now. It's just. I mean, the
Yeah,
thing
we had
is,
like 3 hours of
Use
him just yelling at
3,000
everybody,
use
so we can't do
3,000
it.
and
Car,
1,000.
yeah, is it Carly? The
You just call
problem
me
is
Carl,
that
dude.
the 1,000 miles an hour claim is at the equator, not at the above the equator. That will be that the Earth is rotating according to your model at 1,000 miles an hour at above the equator.
Hey, you guys are
Right.
putting yourself on a cylinder if you think it's the case everywhere.
He just
No,
used
well,
whole numbers for the methodology real quick. It wasn't. I mean, you would have to ask him, but I don't think he was using the actual number. It's not 3,000 miles, so it
That's
couldn't
what
be.
you just said.
but
But the given distance isn't actually 3,000 miles, so it couldn't be.
And
he's
I
just
mean,
trying to
wouldn't
give you
that
an
be the ground
example.
speed anyways? So
He's just trying to give you an example of how you can calculate it.
yeah, but wouldn't that
And
be
my whole
ground
thing is, if
speed?
you calculate it, let's say you calculated it at the equator and you found it was 1,000 miles per hour, why would that be different off the equator all of a sudden? Unless
Oh,
you
that's
think the sun
perfectly
just
fine.
speeds up
That's
and slows
perfectly
down.
fine. So, and it loops around itself in 24 hours?
Well, apparently the sun goes in, and this is in. Well, I mean, I know y'all don't have a model that everyone ascribes to, but this is the general consensus that I get is that the sun goes around in 24 hours,
Yeah, so that would make it 24,000 miles roughly, right?
roughly, which would mean it
Yeah,
would be
that's what
going
the whole
roughly 1,000 miles per
conversation was
hour.
about. That's what our whole conversation has been about.
All right, well then you agree that the sun is moving roughly 1,000 miles per hour.
Yeah, at the equator, right? Which causes the equator to be roughly 24,000 miles.
But I understand you keep saying at the equator, but if the sun's moving 1,000 miles per hour roughly, it doesn't matter if you're at the equator or at the North Pole. It's going to be moving one speed. Unless you telling me that unless the new claim is that the sun, speeds up and slows down.
Oh, I'm not making any claims to that. I was just working within a model. In reality, the sun seems to do a similar. I mean, my days get longer and shorter throughout the year for sure.
In
I don't
reality,
I mean,
know.
yeah.
that's because the sun. That's just because the sun's further away. But no, the sun actually sets way sooner in the winter.
In the northern hemisphere.
Yep, North
No, in the
Hemisphere.
southern hemisphere too.
So does the sun move at roughly 1,000 miles per hour or not?
During the southern summer, you get faster sunsets. I've seen it. I've compared them. The ones that we get during the northern summer are like the sunsets are more drastic and stuff like that. But the ones in the like during the southern summer are like rapid, like within several minutes of it reaching the horizon, it starts disappearing.
Yeah,
All
and
right.
hey, Carl, though you're claiming that the sun is moving at this rate, right? But isn't speed relative? So wouldn't it, in your model or conception, be that the Earth is rotating at that speed,
No, I'm
not
not. I'm
moving
not claiming
speed?
that.
Like, what does
I
What
they
think
I'm
he's
claim?
saying velocity.
I'm not claiming anything. I'm just saying like what he's saying. Obviously, I'm not a flat earther. For you guys, the sun is moving around y'all. So I'm just saying, if the sun is moving around you and we're on a flat Earth, you can calculate that on a flat Earth, right?
Okay.
No, you can clock the probably the ground speed, but you won't be able to actually clock the actual speed because you need to know the distance of the sun and where how fast is it traveling up there.
Okay, okay. I'd like to unmute Kasra just because if it is the case he was just explaining distances, that's perfectly fine. But I need him to answer this. If it is traveling at 1,000 miles an hour on the equinox, let's say, on the equator, right? And in 24 hours it comes back onto itself. Does that describe a circle with around 24,000 mile circumference?
No, it doesn't. This is so embarrassing. It doesn't.
Well, you got to explain that part. That's the part that don't make sense to me because
No,
now you're
I
clear.
was trying. No, I was trying to tell them that how it's easy on a flat Earth model by having the distance between 2 points and having the time difference by just dividing the velocity by time, you can get by dividing the distance by time, you can get your velocity. That's all I was trying to tell you guys. That's it. I'm done. And
Does
if you
Well, I
do
do
the
that, you're
understand that
gonna
part,
does the
but
sun
the question
and
becomes
I
if
built
the sun is moving. Listen, if the sun is moving 1,000 miles per hour on the equator and it comes back around on itself in 24 hours, then you're describing a circle.
now how okay, now this is a very hard claim. Now before we get into this, before we get into this, like I asked a simple question, and instead of giving answers, you guys muted me for 10 minutes. And I told you many times, I'm not benefiting anything out of this conversation. So I taught you how we can use a simple formula to find the velocity of the sun. So next time when a glober comes here and asks these silly questions, you guys don't say, we don't know, we don't know, we don't know. No, of course we know a lot of things. And this is one of those things that we know. The
Well,
velocity is
that's not what
calculated.
happened. We didn't mute you because you asked a simple question. We muted you because you were screaming and
I
preaching and
was
not
in the
listening and
middle
not. It
of
wasn't a
yeah, because I was
conversation.
in the
Like right now,
middle.
you're interrupting me, right? So it wasn't a conversation. You were screaming, you were preaching, you were saying you weren't going to
Who
listen to
interrupted
anybody,
me
you weren't going to answer anything.
now?
So we didn't mute you
Who
for asking a question.
Even
So
now,
Yes,
you're
because
getting emotional, bro. You're
I
like
was
getting
explaining. I was
emotional.
explaining.
It's not the good way. It's
I
not
was ex-
healthy to have a conversation where one person's just screaming and swearing and stuff like that.
no, no,
Like,
it's not.
chill.
Because I know more than you guys. Because I
That's
know.
okay.
This is what it's telling me. That's not what it is.
That's
When
okay,
I'm saying
Those
that,
who
Kasra.
know more
Uh,
are more quiet. Okay, they don't need to scream out
I'm not
information.
that type of person.
Castro,
I really
Carlito
don't.
asked an interesting question because what he was saying, that seems to describe a circle. What does it describe in your worldview? When you say the sun rises right on the
I'm a
equinox in the
peaceful
east,
flat
goes a
earther.
1,000 miles an hour, I turn around, I watch it set, and then all of a sudden it's behind my head again. What does that describe to you?
It describes that it goes and comes back. That's all it is. It doesn't tell you anything. It doesn't talk about the track that is going. Torah. In Torah, you were the person that say we is supposedly that this is what we've been told that it moves with 1,000 miles per hour. When I'll hear from a flat earther who says that this is what we've been told that sun is moving 1,000 miles per hour, this will really hurts me because it tells me that that person really needs some help, and you guys really need some help
It's
here.
not. It's not
You
technically
guys
that.
need
No,
help.
the reason I placed it that way is because one, all motion is relative, right, to the observer, right? So the reason I said that is because that would be like if you tracked it by a ground position, right? Just because it is tracked by a ground position and a miles an hour based on the ground position doesn't mean that's the exact speed it is actually traveling.
Okay, that is okay. I know you want to make it more complicated, and this is what pretty much flat earthers wanted to do whenever they. Oh, we don't know. Yes, it might. This might be the white sun. This might be the projection of the real thing that we're seeing. But
Dude,
the
you're
fucking thing
saying
where
that
I'm.
you think it goes into a portal and just comes back on
No,
itself without
no,
doing a
Make
no,
your
circle.
I never said
jump to
that,
your
bro.
point. Don't no
I
need
never.
to insult or add like, oh, this is what flat earthers do and stuff like that. Just
No, 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 no,
go
no. I never
on
said there's no
opinion.
portal. There's no portal here. I never spoke about portals. I
Okay,
Yeah,
said
for
that
all
Kazra,
of
if
you,
you can't address what other people say here, don't address like, oh, flat earthers always say this. These people always say this. If someone makes a claim, you can address that claim that they say here. But like, I don't want to know what argument you had with the grocery store clerk like an hour ago or whatever, right? I want to know what you think about what's said here, and I want to know what you think, not what we think or they think.
And the claim is it goes back and then comes back to you. It goes away and then comes back to you, right? When we think of a shape, we could think of a circle there. When if we're saying it's a straight line because it seems to be a straight line, in order to get back at the starting point of that straight line, there are necessary consequences. Don't you agree?
Yeah, because you're a Mercator flat earther and you want it to look like a straight line. I do understand that, and I know you. But here's the reality that we're living on it. And as I said, the speed of the sun, it is something that even I'm telling you, an 8 year, not a 12-year-old kid can calculate that for you. And and I'm telling you guys,
I'm
stop it,
fine with that.
please.
I'm fine with the ground speed being
Stop it.
1,000 mile an hour. I'm perfectly fine with that. My question is the shape of what path it's taking.
Okay, you want to know in my model? I'm a two-pole flat Earth model. Just look at my video and see how does it go around.
Doesn't
Where's
that
your
mean
video?
you believe that it's concave, but you guys just say two-pole flat Earth? Isn't
A
that just
concave
like
is
an
a two. Concave
obfuscated way
is
to
a
say
two-pole.
concave or no?
No, a concave is concave is very close to two-pole flat Earth. They're almost the same thing, but the difference is the topology of the Earth. That one is straight, the other one is like a spherical thing. That all is
Okay, so you
different. But the
denounce
The Earth
important
is
concave Earth,
not
you don't
straight,
think it's a concave Earth. Got it. Gotcha.
and the Earth's not straight.
It
In
it
order,
ca-
in
Kasra,
order for me to go outside to make the Earth straight, I have to do things. I have to get out shovels. I have to do a bunch of stuff.
Kasra.
No, that's why it's called topographical plane.
I think Castro's a glober like me. I think he's trolling on.
no, I'm not a
Kasra.
Yeah,
Glober.
no,
I'm a
no,
two-pole.
no. How could you be a Mercator flat earther? Like, I think you said, like, you. I think you're a Mercator flat earther. You can't be a Mercator flat earther because
No,
Yeah,
then
I'm not.
because
you can
No,
clearly see the sun
No, he
appears to
put
make a
that label onto
circle.
me. He put that label onto me because one time I used that argument against him. So now he has
mm,
labeled me as a Mercator flat earther.
You
Yeah,
are not
but
a.
what I'm trying to bring forward to the table is reality.
Yeah,
And it seems for some reason that nobody wants to go into reality. They only want to debate this from their models.
yeah. I mean,
No,
like,
no.
we don't know. Oh, the true dimensions of the Earth. We've had 10 years to model it out, and the globe has had 2,500. And we're just saying, hey, Earth is flat, it's level. We're not making claims about how things work in the
what?
sky.
Yeah, but you don't even mean that. You don't even mean the earth is flat.
The Earth is measurably not flat, guys. And I
Okay,
know
that's
a
a different
guy.
discussion.
I know a guy who does adhere to the Mercator flat map, and he has a woman's name.
Surveying? Does he do surveying?
Um, Not in a professional manner.
Okay, well, you have to give me the physical measurements of the Earth's curvature because I've been looking for it.
Well,
And here's the thing:
how would
when
you
you
measure
say,
it?
I
You're
got a
looking
question
for
for
something
Kasra.
that you don't even have a suggestion on how to find it.
I need a physical measurement of Earth's curvature. Like when we test the Earth, like with radio waves, they go too far.
They go to. I mean, you're asking for a physical measurement of a change in elevation of the Earth. How would you? What tools or methodology would be applied for that?
I would
Find that.
say anything. I think he's talking about anything that's not subject to refraction, right? You wouldn't want anything
Like
that's
if you
subject to
say,
refraction.
yeah, like if you're like, oh, we see the sun changing its declination. That's saying in the
Yeah, like
sky.
those aren't measurements.
What about a water level?
If refraction's
Oh, you
involved,
can't
we can only
use
do that
water
locally,
either.
right? So that doesn't really do much. The local water level, right where you're at.
Yeah, because like
Yeah,
the
locally.
globe is playing, water's
Yeah. Does it
pouring off the
change?
ball. I
Not.
have
I
a
wanted to
video
ask you
about
about
that.
that. Does it change if you go not locally? Does it start curving?
You know what? Not locally is globally.
Yeah, if you're on a globe, obviously the water's gonna. You can't tell that the water's curving unless you go like to really high altitude.
Okay, so every measurement that I take locally sets up with a water level is a tool in reality, right? That sets up a horizontal plane locally, right? And
But what is
all
horizontal?
horizontal planes are parallel.
How do you know that? How do you know that? How do you know that?
You're just looking at the local scale. Like if you
Yeah,
zoom in, zoom out of that level and look at the
yeah. Now
Earth,
you're going
compare
into
your
a
little.
model. You're going into a model right now. Just when I just asked you, can we deal in reality? And you're like, now I gotta go to a God's eye view, something I can't
No,
do. in
The side,
reality.
if you zoomed out of your level onto a globe Earth, your level is way too small to tell
The
if the water was
opposite of
good.
local in the dictionary is global.
You can't use a level to say water doesn't curve
Hey, word salad.
I'm
or
not
that the
saying
ground
that
is not
water
curving
doesn't curve.
or whatever. You can't use a level to try to prove that the Earth is flat.
All right, Globy Salad. What tool would you use to implement a horizontal plane of reference?
I already explained it. When we do things like sending radio waves, they go too far. Those are geometric falsifications of the curvature.
Hey, word salad.
Yeah.
How fast is the sun going when it's raining cats and dogs?
Are you a troll?
Yeah,
No,
this is
I'm
gonna
asking
get
you
catty.
how fast is the sun going when it's raining cats and dogs?
Are you a troll?
Oh my god.
What are you
Do you know the
talking
answer or
about?
no?
Raining cats and dogs. It depends on what you mean. Are you being metaphorical or are you being physical? Because I've encountered some weird trolls on here, so I'm not sure if you are
What's
one
the
or not.
question, bro?
I don't get it. I don't get it either, word cell. But all right, if that's your proof, PNS waves for. I mean, if all there are people who hold to that you can't know anything, you can only falsify. So there are. I mean, if that's the
I mean,
route, you know.
I've seen models that I think Joe Hamby's model is pretty good, but that I don't believe there's this 24-hour sun in Antarctica that like that with the final experiment things and stuff like that. I think there is a type, but it looks more like Joe Hamby's model. And but so like people are like, oh, Joe Hamby's model doesn't work. It doesn't look the same because I don't think that any of the footage that shows the 24-hour sun is legit
I
because
threw
I've
out this.
seen
I
it.
threw out this like retarded conspiracy idea, right? I'm not really too much into conspiracies, but I threw out this retarded conspiracy idea. People were saying that they really rushed like Witsit and Jaron to do it this year, like it was like this year or nothing, and now in hindsight they're saying, oh, we wish we just waited and like kind of prepared for a year. Why do we have to go this year? Then there's these reports that Antarctica has received an ice buildup like never before seen, only this year. So it's something strange happened in Antarctica this year. A couple of
Then
things, I guess.
why don't y'all go? Why don't you
Well,
guys
no,
go?
It's too
uh,
icy now. Now it's big. It's bigger than it's ever been. So I mean,
Well,
we'll get
word
go
lost.
salad.
back to it.
Word
That's
salad.
what she said.
You're gonna have to reconcile the 69 miles per 1 degree and the equator if you're holding to that idea. And this is why I think it's important that we gain knowledge from reality. That's where we gain knowledge, right? Do you agree with that at least?
Yes. But as I said, I don't hold to a certain map. I hold to a general layout.
Yeah, is north a location or a direction?
Depends on what you're talking about. The
Or not
geographic North
north.
Pole or
In
the
reality. I'm
United
talking in reality.
North would be a
Um,
direction and a
I don't like.
location.
Yeah, I think that's loaded. I mean, a direction in relation to what? It wouldn't have to be in relation to something.
Yeah, north, the etymology of it is to the left when the sun rises.
Well, it's a bit difficult. I mean, downtown can be a direction and a location. Got to be more specific than that, haven't you?
Word salad.
Yes.
Absolutely.
The answer to my question is how fast does the sun go when it's raining cats and dogs? The sun's roughly going 9,000 miles per hour.
Oh my
Yeah,
god,
any real flat earther would have
Good
known
one.
that.
y'all need to
Good
move him for
one.
that.
But that wasn't a serious question, as I suspected.
No, that's a
Go
good. That's
back
a
to the
good.
Antarctica thing. Like,
You're
Good
good,
flat
man.
earth joke.
You're good.
No, thanks. You don't think it's interesting with the north and east being perpendicular that when we ask for a way to prove it, people start to tell us to point lasers out in one direction and then hold the compass? This is the flat earthers tell globers to that horizontal and vertical aren't perpendicular. You understand that, right?
Yeah,
You don't use lasers.
I've heard the
I mean,
argument that
lasers don't.
if flat earthers are going to hold that you can't have a tangent to a circle, then they should take issue with latitude north, south, east, west. Yeah.
But
So I feel like
they've accepted the paradox and the paradox would be that there's a location that once you get there, there's only one direction you can travel with no evidence.
How is that? It's not a paradox, though. So this is the trouble. You keep calling it that, but no one else agrees it's a paradox.
You have evidence of it?
What's the paradox? I didn't
Yes,
understand what you
you
meant.
did well, Kaz. You made
Listen,
peace with the paradox.
listen to me carefully, because this is
Paradox in reality.
a genius paradox.
He
Go on,
wanted me
tell
to
him the
explain it
paradox.
real quick, Pazza. Hold on. The
Go
paradox
for it.
is that in reality, north and east are perpendicular to one another. But there is a claim that you could go to a location and then you can only travel south from that location. You can't go perpendicular and travel east or whatever.
And what do you think?
I just deal in reality that north and east are perpendicular to one another. That's how it's been my
So
whole
if
life.
so you think that if you go to the quote unquote North Pole, you wouldn't be able to keep traveling and then go end up
If I
in
go to
like
Narnia,
America or something like that.
if I go to Narnia, what was it?
If you're like in let's say I live in Russia. If you go to if you go from Russia to the North Pole and then you go down south, you would end up in America, right?
But you go north to go south?
You go to the North Pole and
I've
then you
never
just
done
keep.
that in reality.
Okay,
I
yeah,
just go
I'm
north
not
to go
saying you did
north.
it. If you head north, you think that if you that you wouldn't end up eventually going to Russia? I know to America.
If I head north, I'll eventually go south. No, I have never experienced that.
So, are you a bipolar? A bipolar?
I'm just in reality here.
That doesn't make any sense, though.
It doesn't make sense
He's a
to live in
star.
reality.
He's a star
So,
earther.
if you, okay. So you think you don't
I
like
have
claim
been called
any,
I
not
have
even a
been called a
general
star earther.
layout of it?
wait. So
I
what's
mean,
south for you, Tora? In your mind, what's south?
the opposite of north.
So what? So hello. So if you're standing on the North Pole, how
What
do you
North
go east?
Pole? What evidence do you have? Which one? I think there's 5, and they're all
I'm
No,
talking
south
about.
of each other.
I'm talking about for. I'm talking about for
That's for
you.
the Antarctic. North Pole only has like it has the celestial, geographic, and magnetic according to the globe model.
You just named 3 and said there was 2.
What?
Yeah. Well, all right. Like, what if we? All right. So
Well,
if
the
if
celestial
two
and
people are
geographic are
standing at like a
generally
right
the same.
angle to each other, so if they're like on a straight line, and they face the North Star, are they traveling in parallel lines to the North Star? Is North converging, or is it a straight line that's parallel? What do you think, Tor?
I don't know. I don't know.
I
So
face the
What?
North.
you'd be
If
kind
I
of sound
face the
like
North
level Earth
Pole, and
observer.
if I face the North Pole, and where's south faces the North, or faces the North Star, we all face the North Star. Are those parallel lines, Bev?
I don't know. I don't know. I have no idea. Not on a globe.
So
It's
so you're sounding like level
in
Earth
reality,
observer. Would you say?
just in reality.
So you're sounding
In
like
re-
level
in
Earth
re-
observer.
no, in reality, like say I'm in Florida, you're in Arizona, we both face north, and then we start walking that direction. We had to leave
Right
reality
next
into
to,
this hypothetical,
no,
right?
just right next to each other, just
Okay.
10 feet apart.
That will we get closer together eventually?
I can imagine not. I mean, if we're both facing a point, I don't think a point could be parallel to 2 other points in a straight line. I don't see how that's possible. I think it's like a
Yeah, me neither.
paradox.
So that seems kind of strange. So would that make it a globe or what? Especially
Did?
if we take 69 miles per degree the whole way, and we get pi equals 2. What happens now? No tanks.
I don't know if does that happen in reality?
I don't know. Have you tried it? Have you done Are you guys interested in 69ing the globe?
I've never done it. No. I've asked
Yeah,
for it. I mean,
Tora, Tora for ya,
even in the okay.
Tora for ya. You there?
Yes.
Yeah, yeah, I can respect your belief. I think that's a interesting position to hold. And I don't have a problem if you think that.
Have you ever heard of Plato's cave?
Yes, I
Okay.
actually heard of
So
that.
what if all of these things that they've been giving you are the shadows of the wall on the wall, and you just need to get out of the cave and go into reality?
I mean, I believe the scriptures, so
Yeah,
I mean,
exactly. Right. And does the scripture talk about north being a location, or
no,
is it
but talks
or
of
is
the
it a
sun moving in a
direction?
circle.
It says the sun moves in a circuit. Is that what you said?
Yeah, yes,
Yeah,
in Psalm 19.
I can agree with that. The sun moves in a circuit.
Okay.
That doesn't mean there can be plenty. There can be figure 8 circuits, there can be ellipse circuits, there can be circular circuits. Like, I don't know exactly what that means. But what I
Yeah,
do know
I
is that
honestly,
when I try to explain these things, I have to become paradoxical. And what that means is the unknown, right, reveals the truth about God. Because you have to abandon the logos in order to make sense of it, which is sickening that people can abandon logos and think they're making sense of something, right?
yeah,
Abandoning logic.
yeah. So, I honestly don't have a problem with the north, like going to the North Pole and then every direction away from there would be south. I honestly don't think you can go to the North Pole. I think that's where the center of the toroid is, and you wouldn't be able to enter it because you'd be going out of reality. Like you'd be, if you went there, you basically be going out of this world. So you can't enter it except when you die,
Yeah,
and you'd go.
so out of reality. You see that? You see how you had to go to paradox? You have to enter into non-reality. Where are you now?
You're now in the spirit. You would be in the spiritual realm. Basically, you would have to
That
die
that would
in
be a
order
form
to
of
enter out of
reality
this
though.
world.
That would
Kind
be
of
a
like,
form. Would that be a form of reality for you now? So it'd be like a new reality,
I
not a
mean,
non-reality.
what depends on definitions. Then we start talking about semantics and stuff like that. But
I agree with you that you need to be given a new body before you can enter into the heavens.
yeah,
I'm with you.
okay, yeah. Um, the thing about the 69 miles per degree, I'll have to look more into that. Okay, and honestly, I think like the stars and stuff like they aren't physical things. Like they're probably like projected in by an electromagnetic torus field. Um, there's actually a video on my channel. I didn't make it, but it's in
I
a
think I know
playlist
which one
about
you're
it.
talking about. Yeah, it has the yellow uh, thumbnail. It's like a yellow
Oh
toroid
yeah,
field. Yep, yeah, I've seen
yeah,
that video. It's very interesting. And the thing that I'm wondering is it possible that it is all Euclidean, right? And our
yeah,
eyes perceive the heavens in a non-Euclidean fashion. So even
yeah.
though all the stars are actually traveling in straight lines, we perceive it as they're curving.
I wonder if that's like kind of what Einstein maybe understood that and kind of just decided to give a pseudoscientific twist to it. Like with space
Of,
time, bending, warping, and objects not really moving in curved paths, but they just look like they're moving in curved paths.
of the 4D
Yeah,
manifold, yeah.
yeah. I kind of took like that null hypothesis approach to the Globers on their claim that the sky doesn't isn't constrained to this hyperbolic geometry, curved visual space, etc., by bringing up the equator, the 0 degrees, defined. I mean, these defined by Polaris being at that 0 degrees. So now, if they, you've heard the argument. You've heard me put it out there before. Like, if that's what defines the equator, Polaris 0 degrees, supposed to be 90 degrees above your head, that means it would be 4,000 feet below them. So they'd have to either say that the Earth's not a globe with Polaris below their feet, or something's pulling, curving the visual space to pull Polaris up to that 0 point on the horizon at the equator. They have to, one or the other, it has to be one or the other. Can't have their cake and eat it too.
Yeah. 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 So, yeah, all this is pretty interesting. Yeah.
It's the whole deal, right? All right, the 24-hour sun in the south is what confirmed in people's mind that it is a globe. And we
Okay. Well, now
reached
you're
a
just
precipice.
reaffirming the consequence. So you're.
No, I understand. I'm talking about a long time ago, right? Long, ages
Oh.
ago. People did this, right? And then we
Okay.
came to this idea that it has to be one of these two things, right? And they pulled out their trump card once again, right? And
Yeah.
so, why are we getting trapped into the idea that it has to be one of these two things? Why are they pitting us against each other? If you go out into the regular world, right, and you go out into reality, you don't find globers like anti flat earthers. You just find normal people. And normal people will tell you, yeah, east is perpendicular to north. Yeah, that's what I've experienced. Yeah, horizontal is perpendicular to vertical, or vertical is perpendicular to horizontal. They all agree. So the only people that are saying this stuff isn't the case are in this room, are here in this community. Now, in reality, everyone else agrees with these base principles.
Hmm. Okay. I thought you were.
Nobody.
I thought I couldn't see who was talking, so I thought you were a Glover saying that because it happens in the north, it can't work on a flat Earth. I'm like, what? That's what the flat Earth model predicts.
There is no flat Earth model, and nobody is saying that horizontal. Me,
Yes,
Tor,
but
me and
there
you
is a
had like
flat
a
Earth model.
3 hour
I have
discussion.
several flat Earth models. They're my brothers, and they live in a different state, but they're flat Earth models because they are models. They look
What?
like models.
Are they hot?
I've never seen a.
No, people call them models, so they are flat Earth models because they are also flat Earthers.
I mean, do
So,
they do photography or anything?
so when I ask
No.
for a model, and I get there is no model. So who's lying?
The
Is it you or them?
globe has no model either, brother.
The globe has a model.
No, it
Yeah,
One
doesn't.
but we
model.
know it. We know it's not that model because it's not a sphere.
No, you don't know
We
it's not that
false
model.
Well, we
we
know
Genesis
it's not a
15.
falsified the
sphere.
globe model. So you don't have a model either. We falsified the globe. For
Oh,
second,
we
even if
wrong.
even let's say we didn't falsify the globe, there
Yeah.
is no quote unquote globe model. We
Let
model
me
out
let me
different phenomenon.
There's
It's
let
the
me
one
put
globe
it this
model.
way to
geochimera
you.
model.
Words out. Let me put it this way to you. When you depict the earth from a God's eye view, could you see that as being a graven image of the earth?
Yeah,
Yeah,
maybe.
do you know in the 10 commandments there's one that says not to do that? Do you know in Job 38 he chastises Job that you will never know? You know in Jeremiah he says
Mhm.
he will cast off all of Israel if anyone can measure the expanse of the heavens and
Hmm.
the earth.
Yeah.
So is
I
it
mean,
possible it is
yeah.
unknowable and the globe is all the unknowables?
Why are we
Is
bringing religion to a scientific debate?
well, words
Wait,
out.
what?
It's not. I'm not bringing in this religion. I'm
No,
not
you're
bringing
using the
in
Bible.
religion.
You're using the Bible.
Oh
I'm
yeah.
Hey, can
No,
I
no.
can I have that guy list those verses again for me so I can jot them down in my tablet here? I just want to take a look at them. What were those verses again?
in Job 38.
Job 38.
I'll
Okay.
give you the exact ones. Hold on. Job 38 is right in the beginning. I know that. And
Okay.
then Job
It's
38,
like
2
2
through
through
6.
9.
And, yeah, or
It's
2
like
through
2 through
9.
9.
And then Jeremiah 31, 37. And then the 10 Commandments
Jeremiah, what was it?
31, 37.
31, 37. Okay. And then was there a third one?
It's just the 10 Commandments. So you could find those in a couple places. I'm trying to remember in Exodus if it's like
That's okay. I can
I mean,
find those. I just wanted the verses that
Sure.
you were listing off. That's fine. Okay, I
Yep.
appreciate that.
You got it, Bob.
I mean, so about yeah, we cannot tell how the heavens work, and yeah, that is what the globe model seems to try to be doing. Like with all the thing of, we know exactly how all these things work in space. They don't know, but they're trying to pretend they know because they want to be like God, basically.
Exactly.
That's not
Right.
true.
And then and then
That's a gross exaggeration.
let,
Because if you
let
ask most scientists, hold on, if you ask most astronomers and scientists who study this stuff, how much about the universe they know, most of them will tell you under 1%.
No,
and
no,
but a
that
lot
I'm
of
not
them too.
saying
A lot of them.
individual
Hold on, real.
scientists as a straw
We're
man. I'm saying as a whole, and in the top people, like basically, not people who just go out and do science. They're doing their job. They're not trying to do that personally. It's like how you guys say. It's kind of like you guys say, "Oh, you think all scientists are lying?" No, we don't. We never said that.
But they can get to God through the globe. They do. Some of them do. Now,
Yeah.
that's and obviously people get to God through the flat Earth or whatever as well.
Mm-hmm.
But is it like a true depiction? Not really. Like both of these aren't going to add up in the end as a true depiction. So it's like, why are we accepting the false dichotomy?
Yeah. I mean, I think sometimes sometimes it's like we got drawn into providing a model because the Globers are so demanding. Show us a map and show us a model. So then we rush to make a model, and then it usually doesn't work because we, first of all, we don't have enough data yet. Second, for all the reasons mentioned, we cannot uh, confirm everything about the Earth because God's creation is too much to model out.
Yeah, we could confirm locally, right? And in reality. That's
It
it.
locally is in reality. Anything that's not locally, I mean, how can you even confirm that?
It's outside of your reality.
Yep. Just
Yeah.
think about it.
But you don't need to know every, like this is the thing, like it's always this thing of the globe Earth had like what 2,500 years to make a model, et cetera, et cetera. But like you don't understand, like you're in 2025, you have all the advantages to make a map and a model.
Yes,
It
but can
should
we
be
freely and
super easy
privately
now.
explore the Earth? Can we freely and privately explore the Earth? Do we have
Doesn't matter. It
ranges of
doesn't
ours like
matter.
America?
Everything you're gonna do is gonna be locally. You're gonna take a measurement locally, and then you're gonna go to another place and take a measurement locally. You cannot make a claim to the entirety after just taking local measurements. That's not how it works. Just because I meet three blonde ladies that say something silly, can I now assume all blonde ladies are silly? That's not how logic works, dude.
No, but you can travel the Earth and you can use that to at least map the continents of the Earth. And once you do that, you will see that it don't work on a flat plane because you're
Okay,
going to come
have
with
you
a
done
heat
that,
map.
Carl? Have you done that, Carl?
Me personally, I don't need to.
Okay, nobody has done that. No
Okay,
single
second, just
person has ever done that.
People have
what
done it.
about
That's how you have maps.
One
That's how you
person
make
has
a map.
traveled the entirety of the all of reality that we know.
Not one person needs to
second?
do it. It
There's
doesn't have to be
plenty.
one person. It could be a
Okay,
conglomerate of people. It could be a lot of people. We could do it.
Okay, yeah,
We
and
have people all
all
over.
of the people on Earth go, yeah, I got a tool in reality, a water level that sets up a horizontal plane of reference locally, and all the verticals are parallel to it. Now what? Now what do we do? All of us took the
okay,
same observation locally.
Nothing because there's nothing wrong with it.
okay. Listen to this. Okay,
Like what the like
when
what the
you wait. Do you know how you navigate? You use compasses. You use stars to try to go out and map the layout of the continents. Do you know how you got the layout of the continents? You took angle measurements to stars, and guess what? The stars, you're making assumptions about them.
Listen, Carl, this is what you do, man.
I don't know.
Get a basketball, right, Carl? You just get a basketball, and you get yourself a stick, and pretend that stick is your plumb bob. Now, hold it onto the basketball up and down, and then put that basketball to your eye, and then look at the horizon of that basketball, and you're gonna see tilt that stick is gonna be tilted in reference to the horizon. Now go to the beach with a plumb bob and hold it up to the ocean, no tilt. Globe debunked with a basketball.
See what I'm talking about? See, that's a troll. That gotta be a
No, no,
troll.
no. You can't do that. You can't do that because the you wouldn't even be able to see the curve at over 60 miles according to the globe. So that wouldn't debunk the globe.
I mean, you're just ignoring the
Debunk.
scale at that point. And that's what I'm saying. Like, you talking about
You're
putting
like
a
an ant on a
SpongeBob
basketball
on
with
a
a stick.
basketball. Man, you're like a
Ants are
you're
small.
more like a
Ants would have
germ
to be
on a
smaller than an ant.
basketball. Man, you're like a germ
You're
on a
smaller than
basketball.
an ant. Yeah, that's smart. Yeah, and yeah, I apologize that he's like kind of straw manning the globe. I mean, not everyone knows about it, but yeah, according to the globe model, you can't even see the curvature at like 60 miles over that actually. So
Nonsense.
you wouldn't be able to
Not in
gauge
that
it.
way. Not to see tilt.
Yeah, you wouldn't see the tilt, but you can measure the drop off if it was a globe, but couldn't
Yeah,
see the curve.
yeah, that can be measured. The drop off.
Yeah, which we've measured no drop off with radio waves.
Well, that's a claim.
No, you can look up a LoRa LOR, no LORA. They sent a radio frequency from a boat 15 feet high to a buoy 830 miles away, and it was a frequency of over 900 megahertz, so it couldn't bounce off the ionosphere.
And they came to the conclusion that
And
was because of more curvature.
no, there shouldn't have been it should have been blocked at less than 20 miles, but it went 830.
I have to look into that because if it was that easy to
Yeah.
just debunk the globe, everybody would do it all the time,
Well, no, because
and it wouldn't
your
be a
globe model
debate.
is a religion, first of all.
It's definitely not a
So
religion. It's the opposite of a
like
religion. I have a
like
religion, and I hate when
it
people
has
do that. I'm sorry, I don't mean to cut you off, but I have to because I hate when people do that because I actually have a religion. I'm actually a Christian. That is my religion, and
yeah
I'm a Christian by faith. But I also believe the Earth is a globe, and that's not a faith based religion. That's something that I made based on evidence.
no okay. So you don't have a religion, but the globe model is a religion. Okay, you don't know everything about the globe model yet, so you might not see it. But and you could say that like everything you have is a religion because it eventually comes to blind belief in something. But
Well,
yeah.
religions are
Anyway,
usually based. Oh, I'm
wait.
sorry. Go ahead. I'm sorry.
Yeah. So what the globe will claim to excuse that was like some sort of tropospheric ducting, which it should according to like actual science, the area thing that should have been ducting it happens very rarely in small areas. But it would have to be extending 830 miles, which that's like that is a religious claim because it would have to be like these mini clouds that extended 830 miles when they usually very rarely happen in just small areas, like very very small areas, very rarely. But yet somehow it extended all the way there. And second, there should be what's called a skip zone when you send those things, even if you were to grant the magical tropospheric ducting. Um, there'd be a skip zone. So, like, if you draw a triangle, um, the area below the triangle, like if you draw like one line straight out, at an angle going upward, and then that's where it would bounce off the island, so you'd start going down. The area in between that, like inside the triangle, that's called a skip zone where people in that area would not receive it. So the military knows that there should be that on a globe if it's striking the troposphere and ducting down. So they place people in the skip zone to see if it's received, and they receive it all along the area where they shouldn't receive it on a globe. So that means they're receiving it horizontally because it's going horizontally. Not sure if you got that, but yeah. Go
Yeah,
ahead
I was
and
listening,
say what you were
and
saying.
that's a claim I'm gonna have to look into because what ends up happening is, and I'm not trying to be disrespectful here, but when I first came into this server, I asked for all like the flat Earth evidence, and I got a lot. And shout out to my boy Levelist, I see him in here, and New Perspective. They sent me a lot of shit, and like when I started going through that shit, it was certain things that was I'm not gonna say on purpose, but that was left out. I used the Black Swan as an example. People was like, "Oh, we debunked it with the Black Swan," and then I looked into it, and nobody told me about refraction. I had to figure that shit out on myself. So I'll look into your claim. But the whole
Yeah.
religious thing,
Yeah.
I mean, I just fight back against that because, like I said, that's a faith-based position, and the globe isn't something that you can disagree with a person's conclusion, but if he's making that conclusion based upon evidence that he can go out himself and do, and experiments that he can go out himself and do, then at that point, then it's not a religion.
Yeah. Yeah. The normie person is not usually in religion unless like, I'll give you an example. Okay. First of all, I'll say yes. A lot of flat earthers, they don't always they always do leave out sun. That's why when I hear people saying things like, "Oh, Will Duffy said the sun they didn't see a 24-hour sun in Antarctica," I looked at the context and he mistakenly meant moon, but people took that out of context, and I'm like, no, I'm not going to use that because that's not an honest argument. So I personally don't like it when people do that, and not all flat earthers do that, but there are a few who do that. But about the religion thing, let me think real quick. It's more of where they see so much evidence, and then they just come up with these religious excuses that would that makes it unfalsifiable. Like, for example, when you see that sometimes you can see that in the southern summer, if you make observations of sunsets, the sun sets way faster than in the northern summer. And I've actually heard globers say southern hemisphere refraction, where they basically say, oh, because the southern hemisphere might have less pollution, or basically they said the southern hemisphere has more refraction, so it basically extends. No, actually, it has less refraction. Sorry, so it makes it where the sunset is shorter than the north. So that is why I call a religious excuse, because it's like it's a
Hey,
crazy
can I
excuse that doesn't
dude,
make any sense, but it's a
I gotta ask this dude about the black swan,
it's like a
bro. Real
desperate
quick.
attempt to get
When
out
you're done.
without evidence. You broke up there. I didn't hear you.
I gotta ask you about when you brought up the black swan a minute or two ago.
I didn't bring it up.
Oh, that wasn't you who was
I think
mentioned on refraction.
it was the other person.
Oh,
It was the other person. Yeah. I'm not sure if he's here still. Let me see. Who was he?
wasn't it?
Did he leave?
Yeah, it looks like he did. Mm-hmm.
I'm not sure what happened.
Don't worry, I'm used to that kind of stuff. Happens to me all the
Yo,
time.
Rich. Rich, are you there? Rich was claiming some ridiculous things yesterday. He was being ridiculous yesterday in the chat because we were talking about sunsets, and I was trying to explain to him how it works. And then he tried to divert to sunlight under clouds. And I'm like, no, don't divert. We're going to stay on topic. And he's like, well, this is on topic. And then it ended up being a conversation about sunlight under clouds instead of the actual subject, which was about angular size and perspective. And then, yeah, he keeps. I don't like it when the Globers, they divert onto red herring fallacies, and they say, oh, it is on topic, even though it's actually not. It's just a desperate attempt to get out.
Yeah, basically what I call it is they're pulling some Plum Bob SquarePants type of shit.
So, Rich, you should come on in and, like, I know you're not on mute. You should come in and talk.
Probably his handler has seen that I was the one talking to him, and he red flagged him. Said, "Wait till that guy mutes or gets off the channel before you go back on." You know what I mean?
What was that?
I give these federal agents a run for their money, bro. You know what I mean?